So this is the practice final exam version 1. In this, we're going to discuss several problems that may appear in a regular final exam or for a Calculus 2 course. In this version, we are not going to discuss the parametric curves and polar coordinates that can appear in a different version. Um, so rather than providing just the answers, I'm going to go through detailed solutions with for certain problems. I'm going to talk about like a more than one method to solve, and also some possible other versions or variations of certain problems. And I'm also going to give you some of the formulas for like as a review. So that means these methods can be applied to many other problems, not just these problems. So yeah, so let's go one by one. And also you can see that there are more techniques, more discussions for each problem. So the first problem is integrate the following functions, and then also it says use the proper variable. So one of the big problem is that sometimes students like don't use the proper variable, so they ignore all the other variables and try to write all the problems using just one variable, like sometimes like x. That is not really the right way to do it. So please make sure that you use the proper variable. So if it's x variable, use x. If it is t variable or theta, make sure that you use the right variables. It's part of learning. Uh, so let's start with the first problem. So it says that integrate the following functions. So it's just a regular integration problem. So what we normally call the indefinite integrals or like antiderivative. So yeah, so let's pretty much try to find the antiderivatives. So uh, so question number 1, part A. So we have x to the 3 halves minus cosine 2x plus we have 3e negative 6x plus pi. Pi is just a constant. So this is the problem. So what we can do, just integrate term by term. So you can see the first problem is just the power rule. So we're gonna go with the power rule for that. So I'm gonna write some of the formula that we use here. So this is the x to the n dx, that's just the power rule, and we know that this is simply x n plus 1 over n plus 1 plus c. So this is when n not equal to negative 1. Um, so that means this simply going to be, so it is the power is x 3 halves, so you're going to add 1, so that means it's going to be 5 half, and we're going to divide by that. And then the next one is the cosine, and we know this formula. So when you have a cosine with a constant, so what's going to happen is so this is the derivative of sine. So because of that, and then k is a constant, so we divide by the constant and write sine kx. So that's the formula. So we can use that formula here. So it's going to be negative, constant is 1 half. So we simply divide by that. So 1 half the cosine, so it becomes sine 2x. And then the next one is the exponential function. So we know this result. So when you have a exponential constant times x dx, so what normally happens is you just divide by the constant e to the kx. So this only works when k is a constant. So that's the formula we're going to use for the next one. So it is 3 is a constant, so we divided by negative 6, so that's the constant here. So that means it's negative 6 e to the negative 6x plus this is pi. Pi is just a constant, and also we know that from calc 1, if you have a constant, if you integrate this, so it is simply actually not x, just a constant. So if you integrate this one, what's going to happen? Kx plus c. Okay, so those are the formulas that we use here. So that means simply pi x plus c. Now what we normally do is we're going to simplify if we can. So it is 2/5 x to the actually we can write x to the 5 half. Also we can write this using radicals. So what this means is you get an x to the 5th power, take the square root. So you can write it like that if you want. It's not a must, but looks better. So sine 2x, if you simplify this one, this is 1 half e to the negative 6x plus pi x plus c. So that's the answer for the first problem. So let's look at the second part. So second part is we have t cube um, t cube minus square root t minus 3 over t dt, but we know that there are no quotient or product rules when you do integrals. So no quotient or product rules. No quotient or no product rules in integral calculus. No product rules. Good. So because of that, what we normally do is we just use the algebra. We're going to divide by t all the terms. So we can write this step. So we can do t3 over t minus square root t, which is actually t 1 half. So you can write it like that. So t 1 half over t and then negative 3 over t. So that's the first step. So you divide each term by t. Then we can simplify this a little bit. So you can see that this is t squared minus t to the negative 1 half minus 3 over t. We leave it t over 3 because we know the form. There is a form for that, the log form. So we have that. Now what we can do, we can do integrate term by term. So the first step is not really necessary. If you can write it like that, that's fine. So let's write the formula. This one of the formula that we can use here is 1 over x dx, other than the basic power rule. So this is ln absolute value of x plus c. Why we need the absolute sign here? Because we do not have the absolute sign. Let's look at what this looks like. So this is the log graph. So if you look at the log graph, we know that these have two functions like that, two sides. So what happened? If you do not write the absolute sign, you only consider one side. So you can see that only this side. But if you have the absolute sign, that means you can consider both sides. So that means this is like the complete solution, because when you write the integrals, that means you need to write the like antiderivative. Okay, antiderivative means like it's a complete solution. It's not just a part of the solution. So what we normally call the general solution. So in the general solution, you need the absolute sign. So it's very important. Okay, so if you do not write the absolute sign, you want to write 50% of the solution. So you have to be careful with that. Okay, good. So now we can just use the power rule here. So if you use the power rule, you can see that this is 1/3 t cube minus t 1 half over 1 half minus this is 3 ln absolute t plus c. So then you can simplify this one as 1/3 t cube divided by 1 half means multiply by 2. This is square root t, and then minus 3 ln square root t plus c. So that's what you get as the answer for that problem. So let's go to part C. So in part C, what we have is 3 secant theta minus secant squared theta plus 6 divided by theta squared plus 9. So what we're trying to do, we try to identify each with a specific form. So we know that there are several formulas available. So you can find those formulas in the description. So I'll try to follow the common integrals link. So then you can find those common integrals that you need to remember as a calculus 2 student. So I'm going to use some of them here. So for example, I'm going to recall a few of them. We're going to use the secant formula here. So we know that if you have secant, so integral of secant has a log function. So if you have secant x dx, which is equals to natural log secant x plus tan x plus c. So that is the integral for secant. And then we also have secant squared, but secant squared is a derivative of tangent. So that means we do not need a new formula. I'm going to just use x for all the formulas. So secant squared, you don't need any new because that's the derivative of tangent x. So that's what you get for secant. And then we also know the special form when you have x squared plus a constant squared, constant not equal to 0, then it is 1 over a tan inverse arctan x over a. So that's the formulas that we can use for this problem. So that means you can write the solution here. So for the first one, it is 3 natural log secant theta plus tan theta. So that's the first one. For the second one, it is easy. It is secant square. That means simply tangent theta. And then the next one is you can see this 9. 9 means 3 squared. So that means a equal 3. So that means it is simply 6 over 3. 3 means a. Tan inverse theta over 3 plus c. Yeah, we can simplify this just a little bit. So if you simplify, you're gonna get 3 natural log secant theta tan theta. We cannot do much here, and then minus tan theta, and then this is just 2 times tan inverse theta over 3. So that's what you get as the solution for the first problem. Good. So let's move on to the second problem. Problem 2 is about the use of problem. So the substitution method. So what you wanna need to figure out is what is the inside function, what we normally call the inside function. For example, so in the first problem, that's the inside function. So you wanna figure out that, and then we're gonna call it that u, and then take the derivative and plug in. So that's the kind of how you do a u sub problems. So these are u subs. Um, Good. So let's start with the first one, and you can see all four are like that. So let's start with the first one. Um, so in the first problem, what we have is, so it is question number 2 part A. So you're gonna have x minus 1 4 x squared minus 8x plus 3 to the 7th power. So the first thing you notice is what is u. So you can see that so that's the u function. So we're going to start with that. So we're going to say u equal 4x squared minus 8x plus 3, and then take the derivative. Once you take the derivative, you can see that this is 8x minus 8 times dx. That's what we normally do. And then you can see that, so we're going to do like a little bit of manipulation here. So if you look at the derivative, you can see that there's a 8 here. So, but in your formula, in our problem, we only have x minus 1. So what we're going to do, you can see 8 is missing. So we're going to start with that. So that's the first thing we notice. There's a 8 missing. So because of that, what we're going to do is we're going to write this one as we're going to multiply and divide by 8. So we're going to divide outside, we're going to multiply inside. So that's the first step we do. We put that there. So because it's going to make it very easy when you do the problem. So we're gonna do that. If you see that something is missing, we can add that actually dx. Now what we can do, we can substitute. So you can see it's very easy now. So it is gonna be 1 over 8. Now so you can see that this is simply u. So this is simply u. So that means it's gonna be u to the 7th power. And then if you combine 8x with dx, if you combine these two, this is simply du. So that means if you combine those two, you can write this one as du. So that is the problem. Okay, simply comes to that. Now what we can do, we can integrate with the new variable. So new variable is u. So if you use that, then you can see that this is simply 1 over 8. And then this is you add 1, just use the power rule, divided by 8 plus c. Now finally what we can do, we're going to substitute for u. So we say 8 64, so it's a 1 over 64, and then we're going to substitute for u. U means 4 x squared minus 8x plus 3 to the 7th power plus c. So that is the answer. But we know that we also discuss what we call the 4 formula method, or the like a shortcut method. So if it's a shortcut, you can get this answer very quickly. So that's so you can see from this one you can directly come here. So using the 4 formula trick, what we use FF, okay, 4 formula trick. So let's see how to use that for this problem. So I'm going to call the second method, or the 4 formula trick. So this is 4 formula trick. So also you can see the link in the description, and if you are not familiar with that, please look at that video. That's a like very short video, it's like only 15 minutes, and you can learn this shortcut method. That's very easy, especially if you need these topics for like a timed exam, like a like SAT, or actually SAT doesn't have calc 2, but if you need like AP calculus, if you need this method for AP calculus, so maybe the if 4 formula trick would be much would be like handy in those kind of problems, because you can finish the problem very quickly. So so let's talk about that. um, so what is one formula that we discussed? I'm gonna write the formula here. One formula is, so we know that if we have fx to some power n not equal to -1, and also you're gonna see the derivative of that function. If this is the case, what the formula says, that you can simply treat fx just as x. So this is like x to the n. That's what it means. So that means if you do that, what's going to happen if you consider fx just as x? So that means it's going to be fx to the uh, n plus 1 divided by n plus 1. So you can see this is just the power root plus c. So that's a 4 formula trick. You can just do that. So let's see how to do that, because you want to make sure that you see the derivative. That's the important part. If you don't see the derivative, you cannot do it. So let's see how to do a problem like this. So you're going to start with this x minus 1 for x squared minus 8x plus 3 to the 7 dx. So again, we notice that this is the inside function. So we look at the derivative of that. We know that the derivative of that function, so this is what we call inside function. Inside function, in short. So you see that the derivative of the inside function is 8x minus 8. So you can see that the 8 is missing. So that's what we do. We're going to kind of arrange this like that first. So we're going to say 8x minus 8. You multiply and divide. Multiply inside, divide outside. And then we have this part, 4x squared minus 8x plus 3. So you write this step, okay? You write that step. Now you notice that, so if you say that one as the function, this is the derivative. So if you say this is the function, this is the derivative. So that means we can use the power rule, what we normally call the general power rule, okay? General power rule. So if it's general power rule, what's going to happen? You can directly write the solution. So that means it is simply 1 over 8. Now you simply read the inside function just as x. So that means it is 4x squared minus 8x plus 3 to the 8 divided by 8. You can just do that, and plus c, and you can see that's actually the answer. So if you write it in a better form, you can say 1 over 64, and then this is simply going to be 4x squared plus, not plus, minus 8x minus 8x plus 3 to the 8th power plus c. So that is the 4 formula trick, and you can see just one line. Only thing you need to notice it, you have to write this this special line to bring it to the right form, but just write that line and then you can directly write the solution. So this is what we call the 4 formula trick, equation number 1. This is the equation number 1 in the 4 formula trick. So there's a link in the description, and you can look at it, and then you can learn this shortcut method, because this is going to be really quick for many problems that we use the u sub technique. Okay, for the substitution problems we can say this is normally called the general power rule, general power rule. So so we can say here FF, that means the 4 formula trick. Okay, good. I'm just gonna call it 4 formula trick because there are 4 very interesting formulas that you can directly use for these kind of problems. Okay, so let's go to the part 2 of that problem. So in part 2, so this is uh, yes, the same problem, so we don't need that there. So let's go to the next part. In part 2, part B, we have this exponential function e to the secant theta, secant t minus 1 secant t tan t dt. So that's the problem. Now again, you try to figure out what is the inside function, what is u. So you can see that if you get an exponential function, we're gonna pick this part as u. So that's a kind of common trick that we do. When you have exponential function, try to pick the whole thing as u. So if you do that, then you can see that u minus u equals secant t minus 1. Be careful, there is no parenthesis here. So this is secant t and then minus 1. It is not secant t minus 1. Okay, there is no parenthesis here. So so you have to be very careful with that, because don't put unnecessary parenthesis, because that can complicate the problem. So there's no parenthesis means it's just a different part of the function. Good. So now you're going to take the derivative. -1 is just a constant. So if you take the derivative, you're going to get du equal derivative secant means secant t tan t and then dt. Now you can see that's exactly sitting there. So that means this part is simply du. That's exactly what should happen. So I wanna again I wanna tell you that this does not equals to this is not this is not secant t minus 1. You can see, then you have to put an extra t. So this is not what we have here. Okay, so this is not. So be careful with it. Okay, good. Now since we have everything here, so what we can do is we can substitute. So if you substitute, what's gonna happen? It is e to the, this is gonna be simply u, and you can see secant t tan t dd is simply du. So you can see how easy. So this is simply we know the integral of um, ex is ex, so this is eu plus c. The reason is okay, yeah, the reason is we know that the integral of ex dx is ex. Okay, good. So now we're gonna substitute. So it's eu, so it's eu means secant t minus 1 plus c. Good. um, yeah, so you need to be careful with how to use the parentheses. So that's like something that you need to learn how to properly use parentheses or like any kind of brackets. Good. So let's also do the 4 formula trick for this problem. So if you use the 4 formula trick, you can see just very easy. It is e secant t minus 1 secant t tan t dt. Now you can see that the other 4 formula trick is this one. So what is the formula? If you have e to the fx times f prime x, if you see that, if you see the function and its derivative multiplied, then it is simply e to the fx plus c. So that is the formula. So we can use that formula here. So that's another formula that we use. It's again the general power rule. So that means according to that one, you can see, so this is the function, this is the function, and then you can see this is the derivative. So this is just the derivative, f prime, in this case t. So this is ft, or I'm just gonna use fx just for as a formula, but it is ft actually. So that means it's exactly follow the pattern. So that means it's gonna be e simply secant t minus 1 plus c. That's it. So it's simply coming from 4 formula trick. So it's very easy. So if you remember this technique, this math gonna be very easy. Good. So let's go to part C. In part C, we have a problem like this. So this is a trigonometric function 0, pi over 2. We have cosine theta, and then 2 minus sine theta d theta. So if you get a problem like that, never make a substitute. I mean, for this kind of problem, when we this kind of fractions, the substitution has to be for the denominator, not for the numerator. Numerator we always leave for the derivative. So that means the substitution in this case going to be the bottom function. So this part is the u function. So that's something we need to remember. So that means u equal 2 minus sine theta. And then once you take the derivative, and you can see that derivative of sine theta means cosine theta, because the negative sign is a negative cosine theta d theta. Good, that's what you get. And also you can see that there are limits here, so we also calculate the new limits. So original limit for theta equals 0. The new limit is plug in theta equal in the function, so u equal 2 minus sine 0, but we know that sine 0 is 0. Sine 0 is 0. Because of that, this is simply going to be 2, and then theta equal pi over 2, then u equal 2 minus sine pi over 2. Sine pi over 2 is 1, so this is 2 minus 1, so it's 1. The reason is sine pi over 2 is 1. Good. So that means we calculate everything we need. And then you notice that the derivative has a negative sign. Since there is a negative sign, what we can do, we're gonna put a negative sign here. So that means we're gonna put a negative sign outside, and then we're gonna put a negative sign inside, because they cancel each other. And then this is 2 minus sine theta d theta. So we're gonna make these arrangements, preparation. Now we're gonna substitute. So we can substitute for this. So you can see that so this equals negative 0. New limit becomes 2. Pi over 2, new limit become 1. So those are the new numbers. And then a negative cosine theta d theta. Negative cosine theta d theta, this part is simply equals to negative cosine d theta, simply equal to du. So that's simply du. And then 2 minus sine theta is u. So that's what you get. And we know this formula. So this is the log function. So let's do that. So that means this is simply, actually before that you can see the negative sign. So the negative sign, what that does is switch the limit. So that means you can switch it, so you can say 1 to 2 du over u. So you can do it like that. But du over u means natural log, so it's a natural log u, again the absolute value, don't forget that, to 1. Now we're gonna plug in the two values. So if you plug in the two values, you're gonna get ln2, which is positive, so I don't write the absolute sign, minus ln1. But we know that the ln1 is 0, so this is equal to 0. So because of that, the answer is simply ln2. So it's natural log 2. Now, so the interesting part is how we can use the four formula trick for a problem like that. So we're gonna do the four formula trick for this problem as well. So let's see. So we're gonna try four formula method. Four formula method. So if we try the four formula method, we remember this formula. So what's the formula? If we have f prime x over fx dx, this is simply equals to natural log fx plus c. Again, don't forget the absolute sign, because that's a 50% of the answer. Good. Now because of that, so let's start with the problem. So it is 0 pi over 2 cosine theta 2 minus sine theta d theta. The first thing you notice is we look at the function. That's the function, and then this is the derivative, right? I just use x as a formula, but it should be better to use f theta. Okay, good. Now, so you can see the derivative, you need a negative sign, because if you take the derivative of the bottom function, it has to be there should be a negative sign. So because of that, that's the only thing we do. So suppose a negative sign inside, negative sign outside. So that's how we do. So we're gonna do that, and we don't need to calculate new limits if you do you use this trick. So it is 0 pi over 2. Now you can see since the top is the so it will be better to write it here rather than there. So I'm right there. So this is the f theta function. Now this whole thing with the negative sign, now you can see this exactly f prime theta. So I'm gonna take this part out um, with us with there's no negative sign here. Good. So that means it's just a candidate for the four formula trick. So because of the four formula trick, because the top is the derivative of the bottom function, this is simply gonna be a negative. So you can say natural log the bottom function 2 minus sine theta directly. Then limits pi over 2 0. So what do you do? Just plug in the two numbers and so you get the answer. So it's a negative. Plug in pi over 2, so it's a ln 2 minus sine pi over 2, because since this is positive, we don't need the absolute sign. Minus, and then you can see minus minus it becomes plus ln plug in the new value 2 minus sine 0, and you can see that sine 0 is 0, and then sine pi over 2, sine pi over 2 is 1. So that means the first one going to be ln 1, so it's a minus ln 1 minus ln 1. Ln 1 is 0, so that means it's going to go away. That means you simply end up getting ln 2 very quickly. Okay, so that is how you use the four formula trick for that problem, and you can see that uh, so you don't want to go through that u for these kind of problems. You can just write it like that. It's much quicker. Good. So that's about that. So let's talk about the last problem of last part of this problem. So part D. So part D says that 3 square root 2 3 square root 2 x over x squared minus 1 square root dx. For this problem, I'm going to use the four formula trick. You know how to use a substitution, so it's very clear what the substitution is. It is simply u equal this part of the function, so x squared minus 1. But I'm going to use the four formula trick for this problem. So what we can do is we have 3 square root 2, and then we have x there. So I'm going to bring this to the top, so it's x squared minus 1 negative 1/2 dx. And if you look at the inside function, that's inside function, the derivative is 2x. So we only have x, so what I'm going to do, I'm going to multiply and divide by 2. Okay, we do that so you kind of prepare the integral. Now you can see that everything looks great. What we have here is the function. So you can see this is the function, and that's the derivative. Okay, that's the derivative. So that means you can use the general power rule for this problem as we discussed before. So that means according to the four formula trick, so this is simply going to be 1/2. So so you're going to add so just the power rule, so that means it's going to be x squared minus 1. You add 1/2, so it's going to be add 1, so that means it can be 1/2 divided by the same number. That's it. And then you can evaluate this at 3 square root 2. So that's it. And then you can see that this get cancelled, so you're gonna get x squared minus 1 square root evaluated at the two numbers 3 and square root 2. So let's plug in. So if you plug in 3, it's gonna be 8 square root, minus if you plug in square root 2, it's gonna be 1 square root. So that's what you get. So 8 square root means, because 8 you can write as 4 times 2, so that means if you take the square root, it's going to be 2 square root 2 minus 1. So that's the final answer, just using the four formula trick. It's very quick, but you can see that you can try the U substitution for this problem, and you can see that you get the same answer. But this is much quicker. Good. So that's the end of question number 2. So let's go to question number 3. So in this problem, they ask you to find the area, of the region enclosed by the two curves. There are two curves. Um, find the area enclosed by the two curves. So one good thing would be to look at the graph of the function. Then it's because sometimes what happen, if you do not pick the graph properly, you get the negative answers, and sometimes they even cancel each other. So you have to be careful with that. So what we normally do if you get a problem like that, we can look at the graph of these functions. So how to graph this one? First one is easy, y equal x. But the second one, the best thing would be look at the factoring of this. So if you factor x, you can see that this is x times 2 minus x. So what this tells you that at x equals 0, so this is x equals 0. At x equals 0, it's going to cross the y-axis, and x equal 2 is going to cross the at x equals 0 is going to cross the x-axis, and at x equal 2 is also going to cross the x-axis. So we can use that fact, and if you are not familiar with, so, and also you can see that this is a square, that means a quadratic, and the negative sign says that it is concave down. So if you are not familiar with how to graph these kind of simple functions, so please look at the video that I make for how to graph certain functions. So that discuss like all kind of different functions that you need kind of see in calculus classes. So all the linear, quadratic, cubic, root, all the you know absolute functions, even all those common trig functions. So you can find a link in the description for that. Okay, so let's see. In this case, now we know this is a quadratic and concave down. So so it's easy to graph. So that means it's going to be like this. So it is a parabola. It's go through 0 and 2. So it's going to go through 0 and 2. So it's going to go through 0 and 2. Good. And then so the two numbers are, one is 0 and one is 2. The other function is y equal x. So that's easy. So you can draw that. So yeah, so that's the function. That's the y equal x function. So now what we can do is, so this is y equal x. This is y equal 2x minus x squared. Very good. So one thing that we need to do is we need to find where these two graphs meet each other. So for that, what we can do, we're going to calculate that. So for the intersection point, so you can see for the intersection point, what we're going to do, we're going to set the two equations equal. One is x, the other one is 2x minus x squared. So if you bring everything to one side, this simply says that x squared minus x equals 0. And then you can see factoring x minus 1. So that says that x equals 0 and 1. So this says that x equals 0 or x equal 1. So that means the other point is 1. Now what we can do is we're gonna use the formula. So what we normally do is like look at the typical rectangle. So that's the height. So if you call the top function f, the bottom function g, that's the customary way to do that. We're gonna get the height. So height means the difference between the two. So we know the area formula. So the area is simply given by area, whatever the limit, integration of limit, it is the top function minus the bottom function. So top function minus we do that just to get a positive answer. So we always write the top first. So we write the top function and the bottom function. So we do that. So let's plug in the two functions. So first the limits are going from 0 to 1. So you can see those two are, because this one is starting value here, the ending value is there for the region. So that's the region we are talking about. So for this region, those are the starting and ending values. And the top function in this case is the 2x minus x squared minus the bottom function is x dx. So make sure that you use the proper parentheses here, a bracket and the parentheses. Um, so you know that there are three, so we have the parentheses, and then we have the bracket, and then also we have square bracket. So that's the kind of order that it goes. So we start with the simple parentheses and then go to braces and then go to bracket. Good. So this is very easy to integrate. What we normally do, we're gonna expand this. Uh, we're gonna simplify inside first. If you simplify, you can see that you're gonna get x minus x squared dx. So this is a very easy integral. So it is x squared over 2 minus x3 over 3. So we can evaluate this at 1 and 0. If you plug in 0, it is 0. If you plug in 1, you get 1 half minus 1 third. Take the common denominator, which is 6. How to simplify this kind of thing? We multiply this way and we multiply that way and subtract. That's what happened. So that means it's going to be 3 minus 2 over 6. That's like a very simple calculation. So it's 1/6. This is the area, so it is unit squared. So that is the answer for this problem. So it's a very simple problem, but all kind of problems are going to be like that. So one major thing is you need to look at the intersection point first. After you get the intersection point, you can do that. But sometimes what happens, there are certain graphs, they cross each other like multiple times. When you cross each other multiple times, make sure that you split at those intersection points, and always split the integral at either top minus bottom and write like a pieces. For the first one, write one integral. For the second one, write another integral, and then simply evaluate them. So you can see a similar problem like that in the version 2. Okay, so you have to split the integral into two parts. Good. So that's about that. So let's move on to the next problem. So this problem is about the volume problem. So you need to find the volume using one of the methods, either washer or the cell method or the cylinders method. So what we're gonna do is let's try to use both methods and see how what are the differences in the two and which one is easier. So let's start with the washer method. So we can do the washer method first. This is the washer method. So it's always a good idea to like graph the two functions. So so you can see that the graphs looks like that. So this is a parabola. This is a like a y equal x squared, the most simple parabola. So we have this one, and then we have y equal 2x. So that's simply this graph, y equal 2x. So this is y equal 2x, and then this one is y equal x squared. So now again, we need to know what are the intersection points. So this is very easy to see. You can see that it is 2. And if you do not get that, what we can do is for intersection points, I'm going to write that for intersection point, we're going to set the two equal. So x squared equal 2x. And if you bring it to one side, that's like how it works. So it's x minus 2, and you can see that x equal 2 or x equal 0, x equal 2. So those are the intersection points. 0 is already there, the other one is 2. Now what we're going to do is they say that so the question is to find the volume of the solid generated by rotating about the y-axis. So they rotate about the y-axis. It's very important. What axis? So it's rotated about the y-axis. So once you rotate about the y-axis, what's going to happen? So it's going to go like that. So it's going to jump to the other side. So that means so it's going to go, the region are going to go to the other side. So that means that's the point. So it's gonna look like this. So this is a washer method. So we're gonna cut these into washers. So that means a typical washer are gonna look like this. So there's one part right here, the other part is over there. So that's the typical cross section of a washer. So if you use the washer method, and you can see that the washer moving along the y direction, so that means the integral is in with respect to y. So the limit going from 0 to 4. So what we need to do is we need to, so it's a dy problem because the washer is, you can see, is moving. So when you the washer method, you always cut it to perpendicular to the axis of rotation. So it's something you have to remember. You cut it perpendicular to the axis of rotation. So that we do. So we need to calculate two things. We need to calculate the small radius and the larger radius. So this is smaller radius. Uh, yeah. So this is smaller radius. So I'm going to call it like that. And then the large radius. So we have two radii, and you can see that those radius are simply the x coordinates, simply the x coordinate. So because of that, because you need to write everything in terms of y variable, so you're going to solve for y variables. So that's the starting point. So that means, so we have y equal 2x. So that says that x equal y over 2. And then the other one is y equal x squared. So this says that x equal square root y. So those are the two radii. So you can see, so the smaller radius is the line. So that means this is the smaller radius, and the parabola gonna give you the large radius. So those are the two radii. So now we can plug in this to the formula. So let's do that. So the volume is simply pi. So it is CD, we use CD, and then the large radius squared minus smaller radius squared dy. You can see that it's cut along the it's cut from the y-axis, so the thickness is along y. So thickness is along y. Good. So let's plug in here. So we can see that this is simply pi. The limits are going from 0 to 4 because this has to be the y limits. And then so smaller radius, larger radius, that is square root y. So it is square root y, that is square that, minus the smaller radius is y over 2. Y over 2, you're going to square that, and then dy. So let's simplify this first. So it is 0 to pi, you can see 0 to 4, 0 to 4. So you can see this is y minus y squared over 4 dy. So this is very easy to integrate. So this is pi. If you integrate, you're going to get y squared over 2 minus y3. You divide by 3, that means it's going to be 12. And you're going to give it 4 and 0. So let's plug in 4. So if you plug in 4, so you're going to get 16 over 2. And if you plug in 4 in the other one also, it is 64. So it is 64 over 12. And if you simplify, you can see that you're going to get 8 pi over 3. So that's the answer for this problem. And you can see, as a problem, it's not that difficult. But make sure that you cut a curve in the proper direction. Okay, so if the washer method, you have to cut it perpendicular to the axis of rotation. So it's very important. And only in the cylinders method, you're going to cut cylinders with the same axis as the axis of rotation. That's what we can do next. So this problem, you can also use the cylinders method to get the answer. So let's use the cylinders method now and see how it works and which one is easy. So let's talk about the cylinders method now. So we have the same problem. What we have is we have y equal 2x, and also we have y equal x squared. So what we do, we rotate the region around the y-axis. So then we're gonna get this one, and then also we know these the limits are 0 and 2. We know that part as well. So now what we can do, we can do the same problem using the cylinders method now. So we can try to use the cylinders method or the shell method. So if you use the shell method, what we normally do is we're gonna cut it into shells which has the exact same axis as the axis of rotation. So in this case, the axis of rotation is a y-axis. So what we can do, we're gonna cut this into shells, which has the exact same axis of rotation. So that means, so this is gonna be a typical height, uh, and then you can see. So we have this. So that means, so this is the how the shell looks like. So this is how a typical shell looks like. Okay. So, so again, what we need is, in this case, we need the radius of the shell. We normally write r, and we also need to know what is the height of the shell. You can say height is simply the difference in the of the two curves. The radius is simply going to be the x coordinate. You can see that's simply the x coordinate of the x coordinate. Okay, so just the x coordinate. Good. So, so we have everything we need. So that's the radius. So let's plug in the information that we have. Um, so we can see that the radius, which is a function of x, so radius is simply the x coordinate. The height is simply the difference between the two functions. So we normally write f minus g. So in this case, we have the top function is 2x. The bottom function is x squared. So that's what we have. In this case, so we need to do plug into the formula. So we know the volume formula for the shell method is, so this is the volume formula for the shell method is, it is we have 2 pi, and then the limit going from a to b, the radius, height, dx is thickness. So in this case it's a x, variable is x, because you can see that it's going the x direction. uh, the thickness is on the x direction. So let's plug in here. So you can see it is 2 pi, limit going from 0 to 2 in this case, because these are x limits. It's not the y limits, it's the x limits, so 0 to 2. And then radius, which is x, uh, and the height, which is 2x minus x squared dx. If you get a problem like that, there are no product rules. So what we need to do is you distribute that first. So if you distribute, you're gonna get 2x squared minus x cubed. This is a very easy integral. So it is 2 pi. If you integrate, you're gonna get 2/3 x cubed minus x4 over 4. And then you're gonna plug in 2 and 0. If you plug in 0, it's gone. If you plug in 2, you're gonna get 16 over 3 minus 16 over 4. So this is very easy to simplify because you can pull the 16 out. So that means it's going to be 32 pi. You can see that this is just the 32 pi. And then what you have is 1/3 minus 1/4, which is 112. So that means, so you have 32 pi times 112. So you can see that this is 8 pi over 3. This is unit cube because this is a volume. Good. So you can see you get the same answer. And then you can see compared to the calculation, this shell method is much easier in calculation wise. So you can see this is how you use the two methods to a problem like that. But here what you want to remember is you want to cut the cells which have the exact same axis as the axis of rotation. That's something you need to remember. Um, so that's different from the washer method. In the washer method, you're going to cut the washers perpendicular to the axis of rotation. And then here also you need to figure out what is the variable. So in this case you can see that the variables x is the variables, that means you're in the x limits. In the when you have the washer method, it's the variable is the y variable because you're gonna washer is moving along the y direction. So that's the major difference between the two, but you get the same answer at the end. And compared to washer method, a cylinders method is much easier. So there's another video in that like a very short video I discussed, like I consider different regions, and then I consider like how to write different formulas, how to write the you know, the disk method, Boson method, cylinders method for like a pretty much same type of region, but what are the different formulas that you get. So you can see the link in the description for that. That's a short video, and you can kind of learn this very quickly from that if you kind of need more examples. Okay, thank you. So let's move on to the next problem. So problem number 5. So the next problem is about the integration by parts. Integration by parts. We know that when you do integration by parts, we can do the regular technique. That we so what's integration by parts formula? So we have a u dv. You're gonna write this one as uv minus v du. So the goal is to find uv so that this integral is easy compared to the original one. What we normally do is we're going to use this, we're going to remember this one as using Liat, L-I-A-T-E, uh, T-E, T and E. So if you forget what this means, we know that the L means the log function, and the E means like inverse trig functions, inverse functions, not just trigs, inverse functions. And then I'm gonna go for algebraic functions, algebraic, and then trigonometric functions, and then this is exponential. So those are the functions. I mean, this method works most of the time, not 100%, but most of the time it works. So there are few cases that it doesn't work. Good. So now let's try to do one by one. So the goal is to find a u so that so goal is to find u and v so that v du is easy to integrate. So that's the whole point. So and then also we know the di method, and so this is one, and then we use the Liat, and also we have the di method, and also if you forget what is the DI method, there's a link in the description and you can go over that. And I have like solved like about 5 problems using the DI method. That's very useful if you have like a large polynomials, because if you try to use the regular technique, it's going to take long time. So in that case, we normally use the DI method. So you can find the link in the description. So those are the 3 things that you want to remember. So let's go one by one. The first problem, I'm going to use a DI method also, because when you have a polynomial like that, it's always easy to use the DI method because it's very easy. For the other two, I'm going to use the regular technique. So according to this argument, you can clearly see that in the first problem, so this is the u, because the you can see this is like algebraic function that comes before. So this is the preference order. So you're going to start from this side. So that's the preference order. So you can see that algebraic functions comes before the trig functions. So that means the u has to be that, and then the log function is the first one. So that means if you see log functions, that's going to be u. So that's interesting. And then also we have inverse trig functions. That means that has to be according to this rule. So let's do one by one. So let's start with the first one. So the first one, what it says that so we have t minus 1 cosine 2t dt. That's what we have. So according to the rule, we know that this has to be u, because once you take the derivative, it's going to be very simple, and the rest of the function, everything else has to be dv. So not just cosine 2t, cosine 2t dt is dv. Okay, so let's use that now. So that means u equal t minus 1 dv equal cosine 2t dt. So we're going to take the derivative of the first one. So that means du equal dt. Constant going to go away. So that's one of the benefit. And then we integrate this one. Take the derivative of the first one. Take the derivative of the first one. Take the integral of the second one. Okay, so if you integrate this one, this is a cosine. That means it's a sine. So it's a 1/2. That's a constant. Sine 2t. That's what you get. If you have a constant, simply divide by that. So and there's a cosine, so the integral has to be sine. So we have everything. And also you notice that the first line if you have the first line is the integral, second line is the answer. So so you can see that. So if you multiply t minus 1 with cosine 2t dt, that's the problem, and the second one is the answer. Okay, so like that. So that's another way to remember that. Now let's plug in here. So we're gonna plug into the formula. It is u v minus v du, the integral. So let's plug it in there. So uv, so we have 1/2 is a constant. I'm going to write it that first. So uv means that you multiply the u function, the v function. So it is t minus 1 sine uh, sine 2t, sine 2t, and then minus v du. V is again we have a constant. We write the constant in front, so just to make the calculation easier, and then v sine 2t du equal dt. Okay, don't forget the du and dt. Sometimes you forget that that's not, because there's no meaning if you don't write dt here. So 1/2 t minus 1 sine 2t sine 2t, and integral of sine. Integral of sine means negative cosine, so negative negative become positive, divided by that constant, so you have divided by 1/2. That means it's going to be simply 1/4 cosine 2t plus c. So that's the answer if you use a regular technique. It's very easy. So you're going to get that. So again, we use the Liat argument, L-I-A-T-E. Good. So you can see that the 8. Okay. Good. Let's use the DI method for this problem. So if you use the DI method, so what we're gonna do again, it's the same thing. It's the same U and the same V. Here we don't write dV, we just write V. What we do, we take the derivative of the first one. If you take the derivative is 1, we take the integral, so it is 1/2 sine 2t. Take one more derivative. We take derivative until we see 0 if possible. Now here we can integrate as before. So cosine 2t. Now what we do is we start multiplying across the diagonal with the plus sign, and then you switch the sign, so it's going to be minus, and that's it, because you see a 0, so you stop. So that means you can write the solution right away. So that means it's going to be t minus 1 cosine 2t dt, which is equals to 1/2 t minus 1 sine 2t. Okay, so what you do is you multiply the first product, so it is 1/2 t minus 1 sine 2t with the plus sign, and then there's a minus sign, and then you multiply the second two. It is 1 times 1/4, which is 1/4, and then you have cosine 2t plus c. So that's the answer. So we multiply the first product and then we multiply the second product. First product give the first term, second product give the second term. You always start with the plus sign. So you can see it's just one line, especially if you have a larger polynomial, long, complicated polynomial, the DI method be very, very easy. Okay, so let's go to the next one, part B. So in part B, what we have is, so it is 1 to E. So we have 5t to the 4th power, and then we have natural log t dt. So that's what we have. And then we know that according to the argument, when you have log function, we always pick that one as the log function. Everything else combine into dv. So that means u equal ln t, dv equal 5t4 dt. Take the derivative, which is 1 over t times dt. Take the integral. So if you take the integral, you have to you increase by 5, divide by 5, so you get t to the 5. So very simple. Now we're gonna plug into the formula. So if you plug into the formula, so it's gonna be uv. So again, the formula uv minus v du. And then you also need to plug in the values, so that means it's going to be e and 1, e and 1. So that's what you get. So let's plug in. So uv, that means t to the fifth ln t evaluated at e and 1. So this is not an improper integral, so everything is fine. And then here v means t to the fifth. Du is 1 over t dt evaluated at 1 and e. So you can evaluate this one. So I'm going to leave it like that for the moment. So evaluate at e and 1. So here you can see that this is simply t to the fourth dt e1. So that means we evaluate. So I'm still going to repeat like that. But you can evaluate this minus t to the fifth e1. So let's plug in the numbers now. So plug in the numbers, you can see that it is e to the 5 ln e minus 1/5, that means 1, you get only ln 1 minus here e to the fifth minus 5, and then if you plug in 1 you can get that. Now you can see ln 1 is 0, so this is gone. And then you can write the number. So this is 1/5, and also you can see that you can and also we know that the ln e is 1, so this is equals to 1, ln e equal 1. So that means you can combine the e fifth terms. So that means you combine the e to the fifth terms, you're going to get 1 minus 1/5, that means 4/5 e to the fifth. So that's the answer for this problem. Good. So that's about that, and we are not going to use the DI method, especially when you have log functions, because it's a never-ending process. So it'd be easier to use the regular technique for these kind of problems when you do not have this. Good, but still you can use the DI method. You can see a problem in the video. You can find the link in the description. So let's go to the next problem. So the next one is the inverse tan. So x tan inverse x, or the arctan x dx. And according to the rule, we know that we have to pick this one as u. So let's do that. So that means u equal tan inverse x, and everything else. So this part we're gonna pick as dv. So dv equal x dx. Take the derivative. We know that the derivative of tangent is 1 over 1 plus x squared dx. This is the integral, so this is just x squared over 2. And we do not add the plus c, so that's because we are looking for one solution. Okay, now what we can do is we can plug in. So this is equals to uv minus v du. So we're going to plug in here. So if you plug in, you can see that this is 1/2. We write 1/2 out in front. 1/2 tan inverse x minus v means x squared over 2, and then du is 1 over 1 plus x squared dx. So what we can do, we can make some arrangements here. So this is like an interesting problem. What we can do is we write this one tan inverse x 1/2 out. So what we're trying to do is, okay, so what we have is x squared over 1 plus x squared. So the point is, what we're trying to do, we're gonna create a term similar to the denominator. So that means we can this, we have x squared over, because this thing is simply equals to x squared over, this is x squared over 1 plus x squared. So what we're trying to do, we try to create the same denominator in the top. So what we do, we add and subtract 1. So we say we add 1 and we subtract 1 and write it like that. Now you can separate. You can see this term and that term is the same. So if you divide, it's 1 minus. So we can do that. So we can write this one as 1/2 x squared tan inverse x minus 1/2. You can write this one as 1 minus 1 over 1 plus x squared dx. Now you can see that this is 1 half x squared tan inverse x minus, if you integrate this one, you can see this is x, and then minus this is tan inverse. So that's a minus minus, so you can write minus, so it's simply tan inverse x plus c. And then if you simplify this a little bit, or if you combine, because you can see there are two tan inverse terms, so you can combine them. If you combine them with 1 half, you can see that it's a negative negative positive, so you get x squared plus 1 tan inverse x minus 1 half x plus c. So that's what you get for this problem. Very good. So you can see, and again, we are not going to use the DI method for this problem. So the regular technique would be easier. I mean, there's no big difference because it's never ending process. So we use the simple formula, UV formula. Okay, this normally actually considered as a product rule in integral, but it's not really a product. So what we do, we convert the problem to something that is easy. Okay, so let's go to the next problem. So next we have trigonometric integrals. So these are trigonometric integrals. So there are special techniques that you need to use for trigonometric integrals, and if you are not familiar with the techniques, you can look at the video that is solely created for trigonometric integrals. You can find the link in the description. So again, please read the questions, and this is that any two parts, because I'm just giving this one just to tell you what is out there, because sometimes what happen, some of the students forget to read the instructions and try to do all three. It's gonna take time, because even though if you do all three, you do not get time points for all three, because any two is only two. So make sure that you read the instructions. That's one of the very very important things. Sometimes what happen, so there are some problems answer any 2 out of 5. There are some students, they do all 5, but it's simply useless because you do not get any extra points for doing it. So just, and then what happen at the end, you don't have enough time to do all the problems. So please read the instructions. It's one of the very important thing. That's the reason why I give you a problem like that, just to tell you what kind of questions out there. So read the instructions, very important. Okay, so let's start with the first problem, which is a sine cosine problem. So when you have a sine cosine problem, there's a special technique because you need to we're gonna categorize these into two types. One is like a there's at least one odd power. That's the first type. There's at least one odd power. The other type is both even powers. So there's at least one odd power, and then there are both even powers. So if there are at least one odd power, so in this case this, the trick is we use u as the other one. That's how you remember. Just u is the other one. In this case, sine x. So u equal sine x. So that's what you understand. U equals sine x because that's the other one. So that's about that. And then if you have both even powers, what we're gonna do is so this is the other one. Okay, that's like when both odd, when at least one is odd. If both odd, what we normally go with the larger one, because then you can kind of get rid of larger power. So then it means you need to convert only the smaller one. So if both odd, pick the larger one. If at least one, if one odd, pick the other one. Okay, if one odd, pick the other one. If both odd, pick the larger one. That's the first type. The second type is if both are even. If both are even, this technique does not work. So in that case, you have to use the double angle formula, the half angle formula, and then we remember these. So we have to use the half angle formula in this case if both both even. So if you have both even powers, so you have to use the half angle formula. So we know that cosine square theta, which is 1 plus cosine 2 theta over 2, sine square theta, which is 1 minus cosine, it's both cosine 2 theta over 2. So we can use these formulas if both even. If both even, we had used what we call the half angle formula. So that's about sine cosine. If we have a tangent and secant, what we try to do is we try to isolate a secant squared term. If the secant term is even, we try to isolate a secant squared term. So the option would be either isolate a secant squared term and write everything else in terms of tan. So everything else using tan. And then the other one is try to isolate a secant tan term. Try to isolate secant tan and try to write everything else in terms of secant. So that's the kind of idea. Okay, so if you see whether you can isolate a secant squared term and write everything else in terms of tan. In this case, yes, that's what we can do here. And there are moments you try to isolate a secant tan term and try to write everything else in terms of secant. Okay, so actually for this problem you can use any of those methods. Both method works, but there are some problems it's only one technique works. So good. And then the last one is just the formulas. Actually there is a typo. This cannot be cotangent. Uh, so this has to be a tangent. So we're gonna talk about that because especially when you have a zero, so you have to be careful with that. Okay, so let's fix that later. Okay, so let's try to go one by one. So we start with the first one. So the first one says that it is sine 4th power x cosine cube x dx. So as before we see odd power, so that means we're gonna pick the other one. So that means u equal, other means sine x, not sine 4x, sine x. And then the derivative is du, which is cosine x dx. So the whole point is try to isolate a cosine term. That's how we try and do. So that's the starting point. So we're gonna isolate. So I'm gonna write it. Yeah, just write here du equal cosine x dx. So I'm gonna take it out. So the whole point is isolate a cosine term. So that means and then rewrite everything else in terms of sine. Everything else in terms of sine. So isolate that term. So it is sine 4x. That's why it has to be odd power. So we're gonna leave the cosine squared x and then cosine x dx. And then we are not going to do anything with this one because that's the derivative part. We leave it and we write everything else in terms of sine. So we can do that. So that means this is sine is already sine, and we can use the Pythagorean identity. So this is 1 minus sine squared x. We leave this. Now we're going to substitute. So this is simply sine means u. So this is going to be u to the 4th power. This is 1 minus sine means u. So u to the squared. This is simply du. So you can see this is the whole thing is du. So it's going to be du. Now how to do this? There are no product rule. You have to distribute. So we can distribute. So u to the 4th power minus u to the 6th power. And then this is very easy to integrate. So this is u to the 5th over 5th minus u to the 7th over 7 plus c. But don't leave it like that. So we're gonna put the back sign. So that means this is gonna be 1/5 sine 5th 5x minus 1 over 7 sine 7x plus c. Good. So that's the answer, and you can see that it's like a very easy, but you need to know what we do. Okay, so you isolate a cosine term for the derivative and try to write everything else in terms of sine. Okay, that's it. And after we do that, substitute. So you can do many problems using this technique. Many problems. So let's go to the next one. In the next one, we have a secant tan. Uh, so it is a tan 3 theta secant 4 theta d theta. So And we talk about the basics. The idea is see whether you can isolate secant squared and try to write everything else in terms of tan, or isolate secant tan and write everything else in terms of secant. And you can see that for this problem both method works. Okay, and interestingly enough, you can do this problem using 7 different ways. 7 different ways. So I'm going to show you 2 methods for this problem, but you can try the rest. So let's use the obvious option. What's the obvious option? Since you see that the even power here, since you see the even power, we're going to go for u equal tan theta. So that is the obvious one. And then you can see that once you take the derivative, du equal secant squared theta d theta. So that means we can isolate a secant squared term for the derivative. So let's do that. The starting point. So that means this is tan 3 theta. We can isolate a secant squared term, and we leave it because that's the derivative. We don't do anything with that. So everything else we can write in terms of tan. So this is tan 3 theta. This one we can use the Pythagorean identity. We know that the secant squared is 1 plus tan squared. So that's the trigonometric identity. So we leave this one secant squared theta d theta. Now, so yeah, now we're gonna plug in. So we know that this is a tan. So that means this is u to the 3, and this is 1 plus u squared du as before. This is du. Distribute. So this is u to the 3rd plus u to the 5th du. And then this is easy to integrate u to the 4 over 4 plus u to the 6 over 6. Now you're gonna put that back in. U equal tan, so this is 1/4 tan 4 theta plus 1/6 tan 6 theta plus c. So that's the answer. This is just one answer, and you can see that for this problem any of these gonna work. For example, if you pick a u equal tan square theta, you can still do it. So think about the derivative, and I try to isolate that derivative term and try to write everything else in terms of tan squared now. And then you can also try tan cube theta. That still works. You can also try secant theta. You can also do u equal secant square theta. You can also do u equal secant cube theta. You can also do u equal secant 4 theta. So you can try all of them. So that means there are 7 different techniques for this problem. Actually, there are 8. About the 8th one, you can turn this into a sine cosine. So that's the last version. Okay, convert to sine cosine. So, but if you get just a tan secant, don't try to do that because that can, I mean, it can take time. But that's another method. You can convert it to sine cosine and just do a regular sine cosine problem. So that means this problem you can do in like 8 different ways. Okay, so 8 ways. Yeah, you can also figure out more methods, but there are like obvious 8 techniques. Okay, so I'm going to show how to use the secant fourth. So let's do that and see how you're gonna try that. So it's the same problem using this new substitution, u equals secant 4 theta. So we have, it's the same problem. So we have tan 3 theta secant 4 theta d theta. So what we try to do, we're going to use a non-traditional substitution. We're going to say secant 4 theta d theta. So take the derivative. If you take the derivative, this is 4 secant 3 theta, and then you have to multiply by the derivative of the secant function, which is secant theta tan theta according to the chain rule. Now what we can do, we can combine these two. So we can write this one as 4 secant 4 theta tan theta. So that is the derivative. So that means we can isolate this term now. So we are not going to just isolate secant square, but you have to isolate this term because that's the derivative. So let's do that. So that's the starting point. So we can isolate that. So we're going to say tan um, and also you can see that you have to multiply and divide by 4. So let's do that. So we divide by 4, and this is tan square theta, and multiply by 4. So we have secant 4 theta tan theta, and you can see that these two are equal because you multiply and divide by 4, and then we have tan 3 theta secant 4 theta, and we are not gonna touch this. This is just the derivative part, so it's a du part. What we can do, we're gonna write everything, the rest of the integral only using secant 4. Okay, because that's the substitution. So that's a substitution. That means you're going to substitute for u. That means you have to write everything else using secant 4. Then you can substitute the u for that. So how to do that? So that means your starting point going to be tan squared. You can write as secant square theta minus 1. And then I'm going to write du just to save writing. And then it's not really right because you have to write the same variable, but that's okay. Now what we can do, we can write secant 4 theta like this. You can say this is secant 4 theta square root minus 1 because that means square du. Now you can substitute for that. So that means 1/4. So this is u. So it's a u square root minus 1 du. So you can see. So this is a simple integral now. So how to integrate? You know that if you integrate this one, you're gonna get 1/4. So it's a 1/2 power, that means 2/3 u 3/2 minus u with 1, that means minus u plus c. Now you can substitute for u. So if you substitute for u, you can see that 1/4. So we have 2/3. So u means secant 4 theta to the 2/3 minus u means secant 4 theta. So if you simplify this a little bit, you have to take the square root first, and then that means it's going to be 2, and then you're going to raise to the third power, that means 6. And also you can cancel 4 and 2, so that means you finally get 1/6 secant 6 theta minus 1/4 secant 4 theta. Actually, you can show that this answer and the previous answer are equal using the trigonometric identity. Secant square theta equal 1 plus tan square theta. So that's how we use the new technique, and you can see that it's a kind of different integral, so with square root and things like that, but at the end you're going to get the same answer. So that means this is how you use the non-traditional substitution secant 4 theta d theta. Okay, so there's another video that's created to show you all those 7 techniques in one video. So you can watch that later. Okay, so that's about that. So let's go to the last part of this problem. So part number C. So we have this. So we have, so let's say secant x plus cotangent x dx. So let's try to do this problem without the limits. So if we do that, so we know that the cotangent is cosecant over cosine over sine. So that means this is just the formula of problem, because you can see the top is the derivative of the bottom function. This is just the natural log sine x. Okay, so we can do that. And secant x also have a formula. So if you use the formulas, this is simply ln secant x plus tan x plus the formula for cotangent is ln sin x. plus c. So that's what you get. And then you can see the this is part of the common integration tables. So if you are not familiar with that, you can see them in the in a link in the description. Okay, so now if you try to evaluate this at 0, there is a problem. So you can see that there was a 0 here. Pi over 2 is okay, but that's a 0. But at 0, this function is not defined because if you plug 0, it's log 0. Log 0 is not defined because you remember the log graph. So log has a graph like that. So at 0, this function is not defined. So because of that, it's going to go to infinity, negative infinity. So so we're gonna change that, and instead we can do this problem. So we can do 0 to pi over 2. Let's say secant x plus tan x. This one we can do. So again, what is tan? Tan is sine over cosine. That means that you can say you can put a negative sign, negative, negative. Um, so that means it's a negative log cosine. Negative log cosine means log secant. So it's log secant. That's the formula. So that means we can just write the formulas here. So it's ln secant x plus tan x evaluated at, okay, and then yeah, so you can evaluate them separately if you want. So pi over 2 0 plus natural log secant x evaluated at pi over 2 0. Good. So we're gonna get that. Yeah, actually it's not pi over 2, it's pi over 4. So let's change that. So it's pi over 4, pi over 4, and pi over. So we have the same problem there. That pi over 4 tan goes to infinity. So it is like it's gonna be improper integral. So then you have to do that as an improper integral. Good. So let's plug in the values now. So we know that what we know. We know that the cosine pi over 4 equal sine pi over 4 equal square root 2 over 2, or like 1 over square root 2, you can write like that. So that means secant pi over 4 equals square root 2, and if you divide, tan pi over 4 equals 1. So you have those. So that means we can plug in them here. So we plug in that. So this is ln. So we're going to say pi over 4. So that means so secant pi over 4 plus tan pi over 4 minus ln secant 0 plus tan 0. But we know that the tan 0 is 0. Good. Plus the other one is ln secant pi over 4 minus ln secant 0. Again, secant 0 is 1. So tan pi over 4 is also 1. So secant 0 is also 1. So because of that, you can see many terms get cancelled actually. And then also secant pi over 4, that is square root 2. So we're going to get ln 1 plus square root 2 from the first term. The second term is simply 0 because you're going to get ln 1 is 0. So we know that the ln 1 is 0. So because of that, the second term is goes away, and the third term is also goes away because no, actually second term you're going to get ln square root 2, and the third term is ln square root 2, and the fourth term is again 0, and you can combine these two. If you combine, you know that you can multiply the two. If you multiply these two, so you're going to get 2 plus square root 2. So that's the final answer for this problem. Good. So let's go to the next problem. So this is a trig substitution problem. So it's a trig sub problem. So we have three different techniques that we normally use for that. And also it's very important to read the question. It says that answer only one. So just imagine, like, if you do not read these instructions, if you try to do all three, it's going to take too much time, because this kind of problem takes about at least like 10 minutes if you want to write all these steps. So please read the instructions very carefully. It's very, very important. So let's talk about the basics. You know this type. So when you have a squared minus x squared, in this case, you can see that all this problem has a 4, which is a squared. So that means a equal to, we can assume that a is a positive number. So those are the three types. The first type is we have a squared minus x squared. When you have a squared minus x squared, we know the substitution. We're going to say x equal a sine theta. That's a substitution. And then you can see the dx is a cosine theta. So a equal to. For the second one, this is a squared plus x squared type. In this case, t. A squared plus t squared. When you have plus sign, you're going to go for tangent. So that means in this case, t equal a tangent theta. So if you take the derivative dt, which is a secant squared theta dt, squared theta d theta. And then the second type is x squared minus a squared. So this is the x squared minus a squared type. So this one is the a squared plus t squared type. This one is a squared minus x squared. Those are the three types. So that means if you look at the last one, so this is what we normally do is, in this case, x equal a secant theta. Secant theta. And if you take the derivative, you can see that this is a secant theta tan theta d theta. So that's what happened. So those are the three types. So you have to figure out what is the type. But otherwise, after we convert, what's going to happen? This problem become a trigonometric integral problem. So it's a trig integral problem. So that's what we normally do. We convert the algebraic problem into a trigonometric integral problem using these three substitutions. So that's the idea. So we have these three substitutions. We convert the problem into a trigonometric integral problem. So let's go through all three problems. But in the exam, please make sure that you read the instructions carefully, because it may be like something like that. So let's start with the first problem. In the first one, we have 4 minus x squared problem. So let's do that. So this is number 7, part A. So the problem is 1 over 4 minus x squared to the 3 halves dx. So this is the problem, and then we know that in this case a is 2 squared. So this is 4 is 2 squared. So because of that, x is going to be 2 sine theta. So take the derivative, dx equal to cosine theta d theta. So let's plug in that. So if you plug in that, so I'm going to write all these steps, but you can see that there are some steps, those are not really necessary. 4 minus, if you plug in there, it's going to be 4 sine squared theta, and then we have 3 halves dx is 2 cosine theta d theta. Now so let's see how to simplify this one. This is 4. You can see that 4 is a common factor, so you can take the common factor out, but it's into 3 halves. So if you want, you can write it like that. So it is 4 into 3 halves, and then we have 1 minus sine squared. So 1 minus sine squared means, so if you take that, yeah, let's write it. 1 minus sine squared. This step is not really necessary. If you notice that 1 minus sine squared is simply cosine squared, because this is simply cosine squared theta. and then 2 cosine theta d theta. So the next step gonna be 4. 3 halves means 8 because it has square root, which is 2 cube 8. So 8, and then we have 2 there, so that means gonna be 1/4. So it is you can write, actually you can write 1/4 outside just to make the calculation looks like simple. Take it out. So we have 1 over. So this gonna be cosine square theta 3 halves, and then this is cosine theta d theta. So you can see that cosine square 3 halves means 2 get cancelled. So it's simply going to be cube. So that means 1/4 1 over cosine square theta cosine theta d theta, not square, cube. So you can see that one of them get cancelled. So that means you're gonna get 1/4 cos 1/4 1 over cosine square theta d theta. This is 1 over secant square theta d theta, and we know that this is a easy one. Secant squared means tangent, so that means 1/4 tan theta plus c. Now what we can do is we can leave the answer in, because this is a new variable theta, so you have to convert that back into the original variable. So what we can do, we can use a triangle for that. So let's do that. So we can draw the triangle. So this says that x over 2 equals sine theta. So that means we can draw the triangle. So if you draw the triangle, this is sine. Sine means opposite over hypotenuse. So that's x over 2. So you can use a Pythagorean identity. So it's square 4, square 2, that means 4 minus square that and take the square root. That's what you get. This says that tan theta is opposite over hypotenuse. So that's what you get. So that means with this 4, your final answer is going to be 4x over 4 square root 4 minus x squared plus c. So that's the final answer, and you want to make sure that you leave the final answer using the x variable, because theta is something that we introduce, so that's not really the final answer. Good. So let's go to the next problem, our next part. But in the exam you need to answer only one problem like that. Yeah, so this is just the instructions how you do it. Good. And then also, these questions may or may not appear in a regular exam. These are just sample problems. Uh, so the next problem is, which is a, yeah, I'm going to do this problem in 2 different ways. So t 4 plus t squared dt. But if you get a problem like that, you can see the t is the derivative of the bottom function, because the derivative of the bottom function is 2t. 2 is just a number, so we can always manipulate that. So that means the best option for this one is the use up or the 4 formula trick. But if they ask you to use the trigonometric substitution technique, you have to follow that. So let's say in this case, the format tells you that this is a tan substitution, a equal 2, so that means t equal 2 tan theta. So dt equal to secant square theta d theta. That's what you get. So let's plug in that. So that means so t is simply 2 tan theta, and in the bottom it's going to be 4 plus 4 tan square theta to the square root, means 1/2 power, and dt means 2 secant square theta d theta. Good. So let's simplify the rest, and you can see that so we have 2 is 4 tan theta secant square theta d theta, And here what you can do is you can pull 4 out under square root, it's going to be 2. And then we have 1 plus tan squared theta, the 1/2 power, but we know that this is simply a secant squared under square root. It's going to be secant, so that means you can write this one as, and also you can simplify this 2 cancel, you get 2, so you can write 2 outside, so you're going to get tan theta secant squared theta d theta divided by, this is secant squared under square root, this is simply going to be secant theta. Now you can see secant, one secant get cancelled, so you're going to get 2 tan theta secant theta d theta. This is just the derivative of the secant, so this is 2 secant theta plus c. Now the same thing, what are you going to do? We're going to write secant using the t variable. So let's do that. So we do the triangle for that. So this is t over 2 equal tan theta. So so this is theta. Tan means opposite over adjacent. So the hypotenuse is going to be, you square the 2, add and take the square root. So this says that the secant theta, which is hypotenuse over adjacent. So that means if you plug in that, you can see 2 times 4 plus t squared square root over 2 plus c to 2 get cancelled. So you get 4 plus t squared square root plus c. So that's what you get. Simply 4 plus t squared square root. Actually, you can do this problem very simple using the 4 formula trick. Let's see how it is the 4 formula trick to get this problem. You already know, but I'm just telling you how to do that. So 4 formula trick for that problem. So the problem was t over 4 plus t squared square root dt. So you look at the inside function. So the derivative of this function is 2t. So that means we only have t. So what we're going to do is we're going to manipulate that. So we have t. So we have t. We're going to bring this to the top. So it's 4 plus t squared negative 1/2 dt. So derivative is 2t. So we're going to multiply by 2 and divide by 2. So we do that. So that's the manipulation part. Now you can see it's just a 4 formula trick. The reason is this is the inside function and that's the derivative. So we can use a general power rule. So if you use a general power rule, is 1/2. The function is 4 plus t squared. You add 1 divided by that plus c, and you can see that these two get cancelled. If you do that, you will get 4 plus t squared square root plus c. So very simple. So this is how you do the 4 formula trick for this kind of problem. But that's trigonometric substitution is not really the best way to do a problem like that. Okay, so let's go to the last problem. So part C, we have 1 over x squared minus 4 square root dx. Actually, you may remember this is actually one of the formula that we can use. But here we kind of prove in that formula. So the format tells you that there's a minus sign and the x squared is the first one. So that cell says that this is a secant. In this case, a is 2, so it's a 2 secant theta. Take the derivative. So once you take the derivative, dx is 2 secant theta tan theta d theta. So let's plug in that. So if you plug in that, so 1 over, so this is 4 secant squared theta minus 4 square root times dx. dx is 2 secant theta tan theta d theta. We can pull 4 out under square root, so it's going to be 2. And then we have secant square theta minus 1 square root. So 2 secant theta tan theta d theta. Now we also know that secant square theta minus 1 means tan square theta. So under square root, it's going to be tan theta. So 2 uh, tan theta, 2 secant theta tan theta d theta, and you can see that the tan get cancelled. Also 2 get cancelled. Okay, one more thing, when you cancel, it's a good idea to cancel in a different direction. Then if you want to refer back and to check whether you made a mistake, it's a good idea to do it like that, then you know what you did. So that's a kind of make it a practice, like cut in a different angles or different colors. Okay, good. So and then what you end up getting is simply secant theta d theta. This one we know, this is one of the formula. So this is natural log secant theta plus tan theta. Um, this is one of the formula that you want to remember. Now what you want to do, you want to convert your secant tan into these two. Secant you can already get, secant is just x over 2. So this part we know, that's just x over 2, but we don't know tan. So again, we use the same trick. We try to draw the triangle. So this says that x over 2 equals secant theta. In other words, 2 over x equal cosine theta. So let's draw the triangle. This is theta. So cosine, which is 2 over x. So that means this is x squared minus 4 square root. So tan theta is opposite of adjacent. So that means we can plug in those here. Now if you plug in that, so you're going to get ln. Secant means x over 2. Tan means x squared minus 4 over 2. So this is perfectly fine, but you can see that this is a common denominator. And then we can take it out. If you take it out, and then say ln 1 half, that you can combine with c. So it's just a c, it's a constant. So that means finally, if you want, you can write it like that. So ln x plus x squared minus 4 square root plus c. These two c's are not the same, but this is the kind of best answer you can write, because 1 half is, because you try to write the most simplified solution. So that's the most simplified version, but this one is perfectly fine, there's nothing wrong with that, but this is much better if you can remember that step. Good. So we try to write good solutions, very good solutions. Okay, so that's about that. So let's move on to the next problem. um so next problem is about partial fractions. So this is a partial fraction method problem. So we know that when you have partial fractions, there are 3 types. The first type is different linear factors, and the second one is repeated factors. Third one is irreducible factors. It's like a term like that. It's an irreducible term. You know that you can reduce it in the real domain. So those are the 3 types. Distinct linear factors, like terms like x minus a, x minus b type of one. That's the first type. The second type is, you can see like maybe a term like that, but you can see a term like this in the denominator. That's like a repeated factors, like a power other than 1. Third type is we have x minus a, x squared plus b, something like that, what we call irreducible factors. So those 3 are the 3 major types. And if you have a like a improper fraction, what we normally do, we're gonna divide, we do the long division or synthetic division to bring it to a proper fraction. Once you bring it to a proper fraction, it's going to be again one of these 3 types. So that means we can follow those techniques. So here we're going to do the third type problem. So the first thing would be, we can write what we call the partial fraction form, and then try to find the unknowns. So let's talk about that here. So we're gonna we have x squared plus 2x minus 2 divided by x minus 1, x squared plus 4 So which is identical to, don't write the equal sign, this will be identical because we're going to use the properties of identity. It will be identical. So we're gonna go with the easy one first. So we're gonna say we're gonna start with the linear factor a over x minus 1 plus you can see the irreducible factor x squared plus 4. This is a degree 2 polynomial. That means the numerator has to be degree 1. Degree 1 means linear, bx plus c. So that's the format of the partial fraction. Now the goal is to find the three unknown. So what we normally do is we're going to multiply by the common denominator, this denominator both sides. So then we're going to get x squared plus 2x minus 2 identical to a times the other one. So that means x squared plus 4 comes here, and then we have bx plus c. X minus 1 goes there. So always the other one goes to the side. So what we normally do is we're going to use the hybrid method for these kind of problems because that's much quicker. When you use the hybrid technique, we always start with the substitution first. We're going to do substitution as much as we can, and then we're going to go for the coefficient, equating coefficient technique. So let's go for the substitution. So that means we're going to try to get this term 0. To get that term 0, you're going to plug in x equal 1. Those are the zeros of the denominator pretty much. So we're going to substitute x equal 1 to both sides. When you apply x equal 1 on this side, what's going to happen? 1 plus 2 minus 2, that means you get 1 equal, now equal a times 1 squared, that means 1 plus 4, and you can see that the other term gets 0 because you plug in a 0. This says that a is simply 1/5. Good. Now you can see that if you substitute anything else, that's not really going to work, except you can plug in like x equals 0. So that's you can do. Um, so what we normally do is we are not going to do that. We're going to go with the largest coefficient. So let's start with the largest coefficient. That means the coefficient of x squared. Actually, the coefficient of the largest term. X squared is the largest term in any sides. So you can see the coefficient is 1 on this side, and you can see that if you multiply these two terms, you get x squared term. When you multiply these two, you get x squared term. So the coefficient going to be from the first one is a, coefficient of the second one is b. So that means since we already know a, so b is 1 minus a. That means 1 minus 1/5. That means 4/5. So that's the value of b. Very simple. Now what we can do is we can go for the coefficient. You can go to the next coefficient. That's kind of easy. But always see whether how to get least number of terms. So to find c, there are a lot of ways to do. One way to do this is just plug in x equals 0. If you plug in x equals 0, you get a equation which has a and c in there. Since we know a, you can find c. That's one way. Also, you can go for the coefficient. If you can go to the next coefficient, you can avoid a, but you're gonna get b. So that's okay. So let's go for the next coefficient. So always start with the highest one, then you go for the next one. That's gonna make it easy. So the next coefficient, coefficient is 2 on this side. Second, a term doesn't create any x terms, but the next one, to get a x coefficient, you can, one is that negative b is x coefficient because you're gonna get bx negative 1. So that's gonna create an x term. So this one create an x term, and this also create an x term. So those are two x terms. So that means one is negative b, the other one is c. So we are looking for c. So that means c is simply 2 plus b. That means 2 plus b means 4/5. How to simplify this? You multiply and add. Multiply and add. That's what you do. So that means multiply means 10, add means 14. So 14/5. So those are the three coefficients. So you can see it's not that difficult. You can find them very easily. Now what we're gonna do, we're gonna plug in them and integrate. So let's do that next. We're gonna go and substitute that. So we'll start with the problem again. So we have x squared plus 2x minus 2 over x minus 1, x squared minus 4. And also you need to know how to You need to know how to write mathematics properly. That's one of the very important thing. I know there are some students just write everywhere. That's not really like proper way to present something, because you try to present something. Uh, that's exactly one day you can do part of your job. So let's try to learn it the right way. So it's very important how to do something right. So yeah, so let's plug in the values. So we found a is 1/5 over x minus 1, plus b was 4/5 x, and then c was 14/5 over x squared plus 4 dx, and also use the proper brackets there. So these parentheses would be better. Now what we do, first one is easy. You can pull 1/5 out, and then you have the integral of x minus 1. What to do with the second one? Second one, what you can do is you can split into two integrals. So if you look at the bottom, you can see the derivative is 2x. So what we try to do, we try to leave 2x and write the rest outside. So I'm gonna leave 2 there, 2x, and pull only one of the 2's for the first term. From the second term, uh, you can actually 14/5 is a constant, and you can write 1 over x squared plus 4 dx. Now what we can do term by term integration. So this one is 1/5 ln absolute value x minus 1. So here you can see this is the function, and that's the derivative. So that means it's simply going to be natural log. So it is 2/5 ln, and you can see this is positive, so you don't need the absolute sign. So we write the most simplified version. When you write absolute function, that means you have one more function. So if you don't put that unnecessarily. And for the next one, for the last one, that is the tan inverse formula. So the tan inverse formula is, in this case, a equal to, so it's a 1 over 2 tan inverse x over 2 plus c. So that's what you get. So you can simplify this a little bit, and also uh, if you want, you can combine the next first two. That's like extra steps you want. So you can say 1/5, I'm going to write it outside, and then ln. So what we can do is we can combine those into one. So x minus 1 uh, x squared plus 4, because the 2, the second one going to be squared, so that's that. And then here you're going to get 7/5 tan inverse x over 2. So this is like a kind of most simplified form here. Yeah, we would just put the absolute sign for everything just as one single term. Yeah, so that's the solution. But this is like perfectly fine if you write it like that. Good. So let's go to the next problem. Next problem is about sequences. So this problem is about sequences. So there are two types. One is a sequence, the other one is series. So we have sequence and a series. They behave completely different way. Sequence are easy, just a list of numbers, the order matters. So in the first question they're asking so there's a formula given asking you to write the three terms. So that's not that difficult. You're going to plug in the index value and then simplify if you can. And then they're asking see whether they are converging or diverging. If you want to check whether a sequence converge or diverge, there's only one thing to do: check the limit. Check the limit of the nth term. If the limit exists, sequence converge. If the limit does not exist, sequence diverge. Okay. So to check whether a sequence converge, check the limit. Okay, the limit when n goes to infinity should exist. Should exist. That's it. That's the only thing. We check whether the limit exists. It cannot be infinity, it cannot be doesn't exist. It cannot be infinities, it cannot be doesn't exist. So if it is not any of those two cases, three cases, then the sequence converge. It has to be a finite number. That's it. So very simple. So let's go to the so let's write them in detail. So we have so this is number 9, part A. So a sequence given as the nth term. So that's the nth term of the sequence. You know that the sequence can be given as yeah, using the sequence notation like that. Um, Also, you can list the numbers. That's another way to do it. Just list the numbers. So, just list the numbers like that. That's another way. The other one is you just give the an, the nth term like that. So those are the kind of ways we use to write sequences. Okay, so A1 means you plug in 1. So that means it is 3 plus 5 over 2 plus 1. You get 8 third. That's the first term. The second term is A2, so plug in 2. So if you plug in 2, 2 times is 6, 11, so you get 11 over 5. That's the second term. And then A3, the third term, you plug in 3, so you get 14 divided by 7. So those are the first three terms. And then they are checking whether this limit exists. So for that, what we can do, sequence converge. So what we do is we check the limit. That's what we do. Um, that's what we do always for sequence. So there's only one method. Check the limit. So n goes to infinity. So 3n plus 5 over 2n plus 1. So this is a n goes to infinity problem. When n goes to infinity, you only need to worry about the dominating terms. So just those two terms. And you can see that they are in the same degree. That means just the coefficient is the limit. Sometimes we also use the L'Hopital's rule. So this is finite. That means the sequence converge. So the sequence converges. You can say 2, 3 halves. That's it. So we also use sometimes the L'Hopital's rule. So you may use the L'Hopital's rule. But that's a waste of time for this kind of problem because it's a very simple problem. If they have the same degree, so it can be 3n cubed plus 5 over 2n cubed plus 5. N cubed, they are the same. So just the coefficients. But otherwise, what you can do is use the L'Hopital's rule because it's an infinity over infinity problem. So that means the L'Hopital's rule works. Even for this problem, if you take the derivative, you can see derivative is 3 in the top, derivative the 2 in the bottom. So you can also use the L'Hopital's rule if you want. You still get the same answer. Okay, but if you have polynomials, you don't want to do that. It's just very easy. Okay, that's about that. And part B is you are given the n term like that. So it's 310. So you're gonna see 3n squared pi plus 4n divided by 5n plus 12n squared minus 1. So it's a little complicated expression. So if you get something like that, we can use the continuous function theorem. So we check whether this function is continuous. Let's look at this situation. So you have a function, this is a tan function, and we know what the tan graph looks like. So that's the tan function close to 0. So this is pi over 2 and pi over 2. So what do you want to check? We check whether this number, because there's a limit. If there's a limit, this limit is inside in that domain, in somewhere continuous. And you can see that if you look at the limit, so what's going to happen? It's the same argument. You can see that they are polynomials. So that means the limit going to be the ratio of the two dominating terms. So in this case, the two dominating terms would be 3n squared pi. The other one is 12n squared. If you divide the two, you get pi over 4. So pi over 4 is there. So that means it is at a continuity. So the function is continuous at that point. So that means what you can do is you can bring the limit inside. So that's what happens. So that means these are the steps. So in going from n goes to infinity, so we're gonna say limit n goes to infinity 3 10. So we're gonna write this 3n squared pi plus 4n divided by 5n plus 12n squared minus 1. But since the function is continuous in that point, what we can do is we can bring the limit inside. So we're going to bring the limit inside. So it is, we can say 310. So let's bring the limit inside. N goes to infinity. 3n squared pi plus 4n 5n plus 12n squared minus 1. You can see this also infinity or infinity problem. You can use the L'Hopital rule if you want, but you don't need that. I mean, you can, but just take the, because they are same degree, so just take the ratio between the two. So that means you're going to get pi over 4. That works for these kind of problems, especially when it goes to infinity. Only the dominating terms does matter. So that means that's just contributing everything. So that means 3n squared pi over 12n squared. So that means pi over 4. That means 310 pi over 4. That's the limit. Pi over 4 is the limit. But we know that tan pi over 4 is 1. That we know. So that means the answer is 3 times 1, which is 3. So that is the limit of the, so it's going to converge, and the limit is 3 because this is a finite, this exists. So the sequence converge. So sequence converge to 3. Good. So that's about that. So let's move on to the next problem. So next problem is about series. So series is a kind of major topic. You're going to see several problems in any calculus 2 exam. So let's go to the first problem of that type. So in this problem, we are asked to find the sum of the series. So if this is sum of the series, there are only two options. Sum of the series if it converge. So even if it converge, there are only two options if you want to find the sum of the series. So the one option would be it has to be telescoping. Then you can find the actual sum. So the second one would be geometric. We know that in the geometric series, so you can write a geometric series in two different ways. One way to write is a r n. In this case, n going from 0 to infinity. You can write like that, and we know that it's gonna converge to a over a means the first term over 1 minus r. This happen when absolute value of r less than 1. The other option, sometimes we can write this one as a r n. In minus 1. So when you are in minus 1, then you can start with n equal 1. So it's like how you write it, whether n or n minus 1. It's still gonna converge the exact same sum. A is the first term. You can see the first term is still a, because when you apply n equal 1, the r to the 0, which is 1, so you get a. So so that's the one we can do. So we can try to see whether you can write into, bring it to one of those forms, one of these forms. So those are the only two ways to find an actual sum. So there's another technique that we talk about in one of the videos. Like, there are some special series that you can match with a known formula. So there are certain ones, then you can match with common Maclaurin series or Taylor expansion, and then from that you can use the known formula to find the sum. So that's like another technique. For example, we know what is natural log 1 plus x. That's a formula, and we know what is tan inverse x, things like that. And then what we're gonna do, we're gonna match with them. So that's the another. So those are the three techniques to find those series. But there are some other difficult techniques. But in calculus 2 level, those are the three techniques to find the actual sum. So let's see whether we can do any of them using these techniques. So let's go to the first problem. So the first one is so this is 10 part A. So what is that? So it is n going from 1 to infinity. So we have 1 minus negative 2 to the n over 3n. So the goal is you try to see whether you can write using any of those forms. Can you write this term as a something to n like that? But you can see there's a n there. So what we're trying to do, we can isolate those n terms. But also there's a negative sign in between. That means we can split. This sign says that we have to split this into two because we can write this as just one single term. So that's the starting point. So we can split this into two series. So let's go from 1 to infinity. First one you can write 1 over 3n. So that means 1/3 n because you can put 1 inside. Minus the other one is n going from 1 to infinity. The negative sign you write. So then what you can do, you can combine -2 with 3. So you can write this one as negative 2/3 whole thing n. The reason is you can see n is common to those two terms. So that means you can put it in the under one n, under one roof, pretty much. So you can see these are geometric now. So these are geometric. And you have A is 1, so you have 1 R in format. So that's the format. So in the first one, so this is the R. So you can see that the R is 1/3, which is positive, which is less than 1. So that means the series converge. So it's going to converge. So the first one going to converge. Second one you can see absolute value because it's a negative. Uh, So if you look at absolute value, and you can see it is 2/3, which is also less than 1. So that means the second series also converge. So since both converge, we know the sum of the series, if you have two converging series, you can add them. This is going to converge. Uh, so that's the idea. So we have two converging series. So that means if you look at, if you call this term is an, you can see that sigma n converge, because it's the sum of the two converging series, so it has to converge. So that's the idea. Now what we can do is we can find the actual sum. So we know that it is a over if you write the formula, so it is sigma n going from 1 to infinity a r n minus 1, which is a over 1 minus r. That's the formula when absolute value of r less than 1. So we can use that formula. A means the first term. First term you get plug in the first index. So if you plug in the first index, that means n equal 1. If you plug in that, you get 1/3. So that means 1/3 over 1 minus 1/3. That means r minus. Uh, Again, plug in the first index. That means negative 2/3 in the second one, and then 1 minus minus plus, so it becomes plus 2/3. So that's what you get. Now we're going to simplify this, so you're going to get 1/3 over 2/3 minus plus, you can say 2/3. If you add them, it's going to be 5/3. How to simplify? So multiply, add. That's how we do it. And then you can see that you can simplify this easily because you see the same denominators, they cancel out. Same denominator cancel out. So you're gonna get simply 1/2 here, and then 2/5. Now again, how to simplify this? You're gonna do the cross multiplication argument. You're gonna multiply the denominator with the numerator of the other one. So if you do that, you're gonna get 5 plus 4 um, divided by 2. So that means 5 plus 4 means 9. And then the common denominator is 10. So that's the answer. So also remember this trick. So if you have a b plus c d, so what you can do is you're gonna do the cross multiplication, whatever the sign you have. So in this case it's a plus, so it's me ad plus bc divided by bd. So that's the one. If it's a plus sign, if it's a minus sign, ab minus cd, so it's going to be AD minus BC over AD. So those are kind of tricks. Yeah, that's you can find in my another video that I discussed those kind of tricks to simplify certain things. So you can look at that in the description. Okay, but that's how we do it. So it's just very simple. You have to use a formula. You figure out that you can write the n term in the ARN format. So that's the one we are looking for. If you can write it like that, that means it's geometric. Geometric series converge if the absolute value of R, the rate, is less than 1. Good. So that's the first type. The second type is let's look at that. That's the what we call the telescoping series. So let's do problem number 2. So you can see sigma n going from 2 to infinity 2 over n squared minus 1. You can see that this series is almost a p series. It's a 2 you can ignore. So it's a 1 over n squared. Uh, uh, th that means square means 2, so p equal 2, which is greater than 1, so it's going to converge. So this series converge. But the problem is, so we know that it's going to converge. So let's write that. So you can say I'm going to call this is an. So sigma an uh, converges since it is similar to a sigma 1 over n squared, which is a converging p series with p equal to, which is greater than 1. So this is simply the limit comparison test. That's how we were doing. So it's gonna converge. That's just like a short argument. Now what we normally do is we're gonna look at the partial fraction decomposition. So that's how we're trying to do. Let's start with the argument. So what we normally do, we're gonna see whether you can write the nth term as a difference of two consecutive terms. So that's how we're trying to do. So we notice that, so we have 2 over n squared minus 1, which is equals to 2. We can look at the factors. The factors are in minus 1 and in plus 1. Those are the two factors. Now what we do, we can write this as a partial fraction. So it's a over n minus 1 plus b over n plus 1. Now the standard argument, so we can write this one as 2 equal a the other one plus b the other one, and then we're going to substitute. So we're going to substitute x equal 1. If you do that, you're going to get 2 equal a 1 plus 1 plus 0. This says that a equal 1, and then if you substitute x, not x actually, this is n, n equal negative 1, you can see that you get 0 plus b negative 2. So this says that b equal negative 1. So that means we're going to get the partial fraction decomposition here. So you can see that 2 over n minus 1 equals to, now you can write equal. A is 1, so 1 over n minus 1 minus, and the minus sign in front, 1 over n plus 1. And you can see these are two consecutive terms. They have the same format. And what we can do is we can use that to write first few terms and then think about the limit, then you can find the sum. So let's do that now. So we can see that, so in going from 2 to infinity, 2 over n squared minus 1, you can write this one. If you replace the n term by the partial fraction decomposition we found, it is 1 over n minus 1 minus 1 over n plus 1. So you can see that this is telescoping now. So this is telescoping, because you can write this as a difference of two consecutive terms. So what we normally do is we can look at the partial sum. So it's a1 plus a2 plus a3 plus like that. So we're going to add the first n terms. So let's plug in the first index value. So the first index value is n equal 2. So that's the first index value. So if you plug in first index value, it is 1 over, if you plug in 2, it is 1 minus 1 over 2. Actually 1 over 3 in this case, because we plug n equal 2. So 1 over 3, that's the first one. So this you're going to get when you plug in n equal 2. So the next number is, we plug in n equal 3 now. If you plug in n equal 3, so it is 1 half minus 1/4. So that's what you get. And then plus, so this is when you plug in n equal 3. So keep doing, then you're going to get n equal, you plug n equal 3, n equal 4. So you get 1/3 minus 1/5. So like that. And the last term, if you plug in n, you're going to get 1 over n minus 1 minus 1 over n plus 1. So now, so that's what. Now we can see whether there are any cancellations, and you can see that 1/3 cancels to 1/3, and then if you look at the next term, you can see that this term get cancels, and if you look at the term after that, and you can see that this get cancels. So like that. So and then also you see that when n goes to infinity, these terms goes to 0, because n is in the denominator, they go 0. So that means what you can do in the limit wise, when n goes to infinity, you only get a 1 plus 1 half. That's what happened, because everything else cancel out and the last terms goes to 0 as n goes to infinity. So that means the sum is infinity is this is simply n going from 2 to infinity, 2 over n squared minus 1 simply converts to 1 plus 1 half, that means 3 halves. So this is a finite number. So that means series converts to this number. So that's what happened in this case. Good. So this is the how you look at a telescoping sum. So let's look at a few more series problems, because that's one of the very important topic. So let's go to let's look at the next problem. So in this problem, what we do is test the convergence of these series using the given test. Because we know that there are some tests they doesn't give you any conclusion. For example, ratio test. If the limit of the ratio is 1, it cannot say anything. Same thing happens in the root test. So there are things like that. But since they're asking to use the special test, what we try and do, we use that test. But for a problem like that, when you have like algebraic expressions like that, it is actually the limit comparison would be the easiest, because you can see this algebraic expression. So if it is algebraic, what we normally do is we use the limit comparison test. So that's something we need to remember, because that's the easiest one. So when you do the algebraic, when you do the limit comparison, we only look at the dominating terms from the numerator and the denominator. So because this is gonna create a new sequence, new series, this is gonna get the nth term. So that's the one we're gonna compare with. So let's see all the steps. We only need to look at the dominating terms from the numerator and the denominator, because n goes to infinity, other terms can disappear. So so let's do part 1. So we have the series, so I'm going to repeat it. So n going from 1 to infinity, n squared minus 3 over 5n 8 plus 5n cube minus 1 square root. So what we're going to do, we're going to compare with the simplified version. So we're going to look at the only the dominating terms. So we're going to compare this with n going from 1 to infinity bn. So you can see where bn, bn is, you look at the dominating terms. So it is n squared from the numerator, 5n 8 square root from the denominator. So if you simplify this one, this is n squared, this is square root 5 n to the fourth. That means n squared, not n squared get cancelled. So you're gonna get 1 over square root 5 n squared. So that is the term you're gonna, that is the series we're gonna compare. The term, series with that term. So that's the nth term of this new series. So let's do that now. So what we normally do in the limit comparison, we're gonna consider this term as an, and bn is the given one. So let's write the limit. So it's a limit n goes to infinity. We normally write bn first and then like that. Uh, just for completeness, let's write all here. But the way we selected this limit always going to be 1 because we picked the whole term. So it's upside down, it's divisions, that means upside down. And you can see since we select the whole term, so this is exactly the upside down. So that means this limit is 1. Always the way we selected it because we keep the square root 5 there. Good. So you see that this is not equal to 0. That's the condition. It cannot be 0. And then also we know that the square root 5 is just a constant. So you can pull the square root out. So what we know that, but the sigma 1 over square root 5 in square 1 over square root 5 you can pull out because you can write this one as 1 over square root 5 sigma 1 over n square is a converging p series, is a converging p series, is a converging p series with p which is equal to 2, which is greater than 1. If you know that if p is greater than 1, it's going to converge. So therefore, so what the limit comparison test says, limit comparison test says if the limit is anything other than 0, if it is not, if it's a constant, actually if it's a constant, the same thing will happen to both series. As I say, the same thing will happen to both series. So that means if one converges, the other one converges. Since one series converge, this has to converge. So therefore the original series sigma n therefore sigma n converges by the limit comparison test. You have to mention what the test is. Okay, good. So that's how we do it. It's a very simple problem, but that's only everything you need to write for that problem. Okay, so let's go to the next one. So next one is the ratio test problem. Actually, why it is ratio? So you can see the 3n term. The 3n term tell you that it is either ratio or root test. You can use both of them for this problem. So we're gonna do both for this problem just for your knowledge. So let's use the ratio test first. So part B. So the ratio test. Yeah. So let's try the problem first and go with that. So that's easy. So we have a sigma n going from 1 to infinity, -1 n over 3. The 3n tells you that's a ratio test. So we normally need the next term. So we plug in n plus 1. So this is n plus 1 over 3n plus 1. So let's go with the ratio test. So if you need the ratio test, we look at the ratio. So the limit n goes to infinity, a n plus 1 over a n. You change the index value. So it's the limit n goes to infinity. So it's absolute value -1 n plus 1 over 3n plus 1. Now you can divide an. That means, so an means this term. So this is an. This whole term is an. So that means it's upside down. It's a division. That means you're gonna flip it over. That means 3n goes there, -1n goes down, n goes down because it's upside down. Now what we normally do is we're gonna collect similar terms, and also you can see that since the absolute value, this is 1, this is 1, so we can disregard those two. um, so we're going to collect similar terms, and also these terms are positive, so you don't need the absolute anymore. We can normally what we do is we're going to collect similar terms. So what are similar terms here? So you can see n plus 1 over n is similar, and also 3n over 3n plus 1 is similar. So that's what we normally do. We collect the similar terms. Now you can look at these limits separately, and how to simplify this. You can see 3n cancel with 3n, so you have only 3 to the 1 left. So that means, and also we know that when n goes to infinity, this limit is equals to 1. So that means what happen is you only get 1/3 here. So that's the only thing gonna left, because limit n plus 1, now n goes to 1. So you have 3 to the 1 left as 1/3. So this is less than 1. So that means series gonna converge. So they converge absolutely. So that implies series converge. So very simple, by the ratio test, because it's a number less than 1. It can be 0, okay, 0 or any number less than 1. So that means by the ratio test series can converge. Okay, so by the ratio test is converge absolutely, and then that means it's going to converge. Good. So that's it. That's everything we need to write here. But I'm going to show you. Yeah, actually, what is the argument? So let's say we normally call this is the raw value. So I'm going to write since. Let's complete this. Since a row which is 1/3 less than 1, series converges by the ratio test. So that's the argument. Okay, so let's use the root test to see how it works here. So what's the root test? We do a similar one. What we do, we look at the limit when n goes to infinity, nth root of the nth term under absolute value sign. So let's take the nth root. So the nth root is the limit n goes to infinity, a -1 n 3 to the n absolute value nth root. Again, since the absolute value we don't need that, that's 1. Now what you can do is you have two terms, so we're going to put a 1 over n to both. So if we do that, I'm going to write all the steps here, but some steps are not necessary. If you put that to the top, it is 1 over n. If that to the bottom, it is 3n 1 over n. But you can see that this n and that n get cancelled. But what happens the top? Top, you can see that this limit goes to 1 when n goes to infinity. So that means what you get is simply 1/3, which is less than 1. So that means by the root test, series can converge. Okay, so so you can say again, since row which is 1/3 less than 1, series converge, actually absolutely converge by the root test. So you can see that the algebra is simple in under the root test. So if you do not see factorial terms, try to use the root test, because if you have factorial term you can use the root test, because it's going to be infinity when you have factorial, but still the ratio test works. Okay, so but if you do not have factorial terms, the root test can be much simpler. Good. So that's about that. So that means you can use the root test and the ratio test for a problem like that. Good. So let's continue. So let's try to do a problem using Taylor series, Taylor expansions. So how about the next problem? So in this problem, what we need to do is we find the Taylor series about a different point. It's not 0. If it is about 0, we know that if a equals 0, we know that that's what we normally call the Maclaurin series. So if it is anything other than that, we call it is a Taylor series. So the Maclaurin series is just a special case of the Taylor series when a equals 0. Yeah, it should be a. So, but they're asking find only the first four terms. So be careful with that. So they say find the first four terms. So we know that what we need is the derivatives. So let's go for that. So we have fx equal e to the 2x. So we're going to plug in the constant here. So it is f3 equal 3. If you plug in 3, so it is e to the 2 times 3. So e to the 6. Now take the first derivative. You know that is a 2e 2x. Evaluate at 3. So you get 2e6. And keep doing. So we're going to get second derivative. So you're going to see 2 square, you get one more 2, so it's 2x. So if second derivative 3, so you have 3 here, so it is 2 squared e6. So like that. So you can write the general one, so the nth derivative, so it is 2 to the n, because when every time you take a derivative 2 comes out, so it's a 2 e to the 2x. So this is f nx, so it is 2 to the n e6. That's what you get. Now what we can do is we can plug in that into the formula. So they are asking find only the first four terms. So that means we are looking for the because it's the first four terms, that means it is a degree 3 polynomial. So let's do that. uh, so that means we are looking for t3x. So if you write the formula, it is fa, and then f prime a factorial 1 x minus a, and then we have f double prime a factorial 2 x minus a squared, like that. So we have x minus a cube. So so those are the first four terms. So that means you're gonna get up to 3, one less. So that means this is a degree 3 polynomial. This is a degree 3 third degree polynomial. So we normally use T3. So let's plug in. So it is if a equal 3. So that means you're gonna get e to the 6. The second term was 2e to the 6 x minus 3, and then 4e6 x minus 3 squared, and then 8e6 x minus 3 cube. So that's what you get. So that's the third. Those are the four terms. So we can even write the general term. So let's write the general term. So that means the n going from 0 to infinity, f n a divided by factorial n x minus a n. So this is a formula that we need to remember. So you can see that n is in 4 places: 1, 2, 3, and outside. So that's the formula. It's all n, and that's a. We evaluated the nth derivative at a. So now what we can do, we can just plug in here. So if you plug in, so you're going to get sigma n going from 0 to infinity to n e to the 6 divided by factorial n x minus 3 n. So you can pull e to the 6 out because it's a constant. So we're going to leave only the terms that going to change. So this is 2 to the n factorial x minus 3 to the n. So we can see that there's a factorial n and n star with 0. That's okay. So the reason is we know that the n factorial is 1. It's not 0. So that means you can divide by n factorial, but you cannot divide by n because n can be 0. Okay, so that's about that. So this is what we call the nth degree Taylor polynomial. So in this case, the third degree Taylor polynomial, that's what we found because it's up to degree 3. Okay, when you expand, you get x cubed term. You get x cubed term plus more terms. So that's why it's a degree 3 polynomial. This is degree 3. Okay, so it is degree 3. So degree 3 polynomial. Good. So that's about that. So let's go to the next problem. Our next problem is about more series. So let's pay a little bit more attention to that. So let's go to question number 13. So this is the last problem. It's problem number 13. So there can be, I mean, there are problems like that. So you're gonna get multiple options, but it's not always the case. So it's depending on people to people. So in this problem there are like three different type of problems. The first problem is about testing the convergence of the series. So it doesn't tell you what test, so you need to figure out what is the test looking at the format of the problem. So we can discuss that. And also there's another problem, we try to find the radius of convergence. So radius of convergence also normally comes with the interval of convergence. So we can do that part also for this problem. We can do both radius and interval. And the last problem is about a series representation. So this is a really powerful thing that we need to know, as a calculus 2 student. So we can do that problem. So this can be like three different problems, or maybe like with options like that. So these are kind of common thing that so make sure that you read the instructions, very important, because if you don't read the instructions and you try to do all these questions, you do not have that much time in the exam. So be careful, always read the instructions very carefully. So let's do all these types. So let's start with the first one. The first one is like first four parts. That's about testing series. So let's go for that. Uh, Good. And also you need to mention what test you use. So it's very important. You can't just say converge or diode. You don't get point for that. So you need to mention this is a test, this is a conclusion, like that. Good. So the first part. So this is question number 13, part A. So what is that? So we have this series sigma n going from 1 to infinity, n minus sine n squared over n 3 plus 4. So that's the problem. So if you get a problem like that, this looks like algebraic. So when you see algebraic, so the best thing would be to use the first try to see whether you can directly use the direct comparison test, because that can be very easy for most of the problems if you can use that. But when you try to use the direct comparison test, you have to be careful, but I'm going to discuss that later. First, let's see, because this looks like kind of algebraic type problem, except the sine term. Sine term is okay because we know the sine terms always stay with between 1 and -1, so that doesn't contribute much. So that means we can ignore that term. If you have sine or cosine, you can ignore tan. If you have sine cosine, most of the time you can ignore that term because that does not contribute much. So that means you can look at this problem as just the ratio between those two, because those are the two dominating terms. So that means we're gonna compare this with this series n going from 1 to infinity, uh, n over n squared, that means 1 over n squared, because this is simply n over n cube. That's gonna simplify to 1 over n squared. So you can see this is just a p series, converging p series. So you know that this is a p series, p equal 2, which is greater than 1, so converge. So this is a converging p series. That means if the limit is, because the way we selected limit is 1, so that means this series has to converge. Very simple. Okay, so we look at the limit. So we're gonna say this is an, this whole term, and this is bn. So that's the bn term. So let's look at the limit. So it's the limit n goes to infinity, an over bn. I'm gonna write everything just for completeness, but the way we selected is always the limit is 1. So n minus sine n squared over n 3 plus 4 times upside down, that means n squared over 1. And you can see that this term is 1 over n squared. So it's a 1 over n squared. With this n squared, you're going to cancel out. And why we can ignore sine n squared? Because we can see that it is always in between negative 1 and 1. So this is always in between negative 1 and 1. That means it's not going to contribute. If n goes to infinity, that's why we can do it. N goes to infinity, so you can ignore that term. So this is, we don't need that. So that means in the limit wise, what's going to happen? This is going to go to 1. So this 1 1 which is not equal to 0. So that's exactly the condition we need. Um, so that means we can use by the limit comparison test. So that's how we use limit comparison test. Sigma n, that's the original one, converges since sigma bn is converging. Okay, it's a converging p series with p greater than 1. Good. So that's a very simple argument. So the test that we use is the limit comparison test. So now the question is, can we use the direct comparison? Because if we can use the direct comparison, this problem can be really easy. So let's say let's talk about that. So how about direct comparison test? So but when you want to use the direct comparison, let's make the discussion here. So what is the direct comparison test? We can use the direct comparison. So we have two series, AN versus BN. So you can use the direct comparison test if if AN term is less than BN, where BN is a converging series. So if you can bound by a converging series, bound uh, uh, by the top. So if you can bound above by a converging series, then the small one converge. That we know. And then the other one is bounded below by a diverging series. See the direction. So this will be diverge. So if it's bounded above by a converging series, it's going to converge because we assume that these terms are all positive. So that's the reason because it's stuck. Uh, yeah. So let's write that also because we assume that these terms are positive or zero. So that's the important part. So here you cannot. It's the other way. But for this one, we assume that it's positive. That's why. So when you bound it, it has to stay inside that. Okay, so those are the two conditions. So if you can bound above by a converging series, the smaller one converge. If you can bound below by a diverging series, it's can diverge. So you have to be pay attention to the limit because what the bottom one says is bigger than a diverging one. So this has to diverge. The top one says is smaller than a converging one, so it has to converge. So that's the kind of argument there. Okay, so that means we try to see whether we can bound this by a converging series. So that's the whole point. So now let's see how we can make an argument. So let's start with what we have. We have n sine n squared over n cubed plus 4, which is less than or equal, but we know that sine n squared is always in between. Even though n squared is positive, sine n squared can be negative. So it can be always in between -1 and +1. So it can be largest when this is -1. That's the largest. So that means, remember n also goes to infinity. That means when this term is -1, it can be the largest. So that's the one. So that means the largest value you can have is n plus 1. So what we're going to do, so that means if you replace that, because we know that this sine n squared can be -1. If it's -1 with the negative sign, it will be +1. So because of that, so that means the 1 is the largest value it can happen here. So what we can do is, rather than putting 1, yeah, so I'm going to write few things. So that means if you write n plus 1, this is bigger. So and in the bottom, because since we divide, when you add, if you remove that, this term can be bigger. So we can write it like that. So that's true because 1 plus 1 can be the biggest here. So if you do that, then it's the largest. Now what we do, this is bigger than, instead of 1, I'm going to put n. So let's say plus n because that's bigger. Why we do that? Then you can simplify. Now this is simply equals to 2n over n cube This is simply 2 over n squared. So that is the comparable one because this is bigger. But we know that that's going to converge. That's a converging because 2 is just a constant. We can ignore that. That's the converging series. So you can write this one as 2 sigma 1 over n squared. This is a p series with p2. That means can converge. That means you can see this is the right direction because that's the converging one. So it's smaller than a converging one. So that means here this one has to converge. So you can say now by the direct comparison test, sigma an, that's the original one, has to converge because it's the direct comparison test. So we can use it, but you need to make this kind of argument. So you need to find the right numbers for that. But if you can find the right numbers, you can see it's very simple. It's like it's just one line and you get the answer. But remember, you have to pick the right direction. It has to be smaller than a converging series if you want to show that it's converging. If you want to show that diverging, show that it is bigger than a diverging series. That's how you're gonna pick it up. So and you can see that this is very easy if you wanna do it. It's easier than the limit comparison because in limit comparison you have to find limits and stuff like that. Here you don't have to do. Just find the right candidate for that. Okay, so that's about that. That's number A. So you can use the direct comparison or the limit comparison. And you can see that you cannot use the ratio test or the root test. They're both gonna fail. Okay, the root test and the ratio test gonna fail. So that's something important. When you have a term like n cube, like constant like that, like n means n to the 1. It's not gonna work. It's only work like when you have terms like 3 to the n, like that. So for these kind of terms, the ratio test and the root test does not work. So if you're ln, those doesn't work. The ratio test doesn't work. Root test doesn't work. Okay. So let's say you're ln, nope. So you cannot. But direct or limit comparison can work, but not the ratio or the root test. It works for this, but not for that. Good. Those are few things that you can remember. Okay, let's go to the next part, part B. So part B says this is the series we have n going from 1 to infinity, n squared plus 3 square root n over 4 n to the 6th power 5n minus 1 square root. So you can see this is heavily algebraic. So since this is heavily algebraic, what we're gonna do is we're gonna use the limit comparison. So we're gonna look at the two dominating terms from the numerator and the denominator. It's not always the first term. Look at the largest term. So that means we can compare this with uh, the simplified form. So what is the simplified form? N squared over 4n6 square root. That means sigma n squared over 2 n to the third. That means sigma. So you have to write the sigma because we are talking the series. Or write the way we did before. We write bn, you're going to simplify bn. That's the other way to write it. Be careful with that. And n going from 1 to infinity. So if you simplify this, now it is 1 over 2 and 2 you can pull that out. So we don't worry about the 2 because that's just a constant. So you can say this is the bn term, and you can see this is the harmonic series. Okay, or p equal 1. So this is the harmonic series. Harmonic series, that means diverge. We know that the harmonic series diverge. So in this case, p equal 1, which is less than or equal. So diverge. Remember, harmonic series diverge. Harmonic means you have to have 1 into the 1. Good. So now we can write the argument there. So it's a limit. N goes to infinity. So we're gonna call this is an. So that's the an, and that's the bn. So it is an over bn. For the limit comparison, it doesn't really matter what you write top. So it's limit. This is just for completeness. So I'm gonna write it the whole thing here. Yeah, you need to know how to write math properly. It's very important because these are logic. So if you write a wrong term or wrong equal sign, wrong less than, greater than sign, the whole argument can be invalid. Okay, so you have to be very careful with how to write math properly. It's one of the very important thing, especially when you write math. And then upside down, so that means 2n over 1. So we know that this simplifies to 1 over 2n, so that means this automatically 1. The way we selected is automatically 1 because this is simply 1 over 2n. This is simply 1 over 2n. So that means they're going to cancel out. Good, so it's 1 not equal 0. That's what we want. So you can say since sigma 1 over 2 and 2 is a constant, so don't worry about that, is a diverging, p series, or you can say harmonic series, diverging harmonic series. Okay, but diverging p series, when you say p series you have to say the p value, so p equal 1 which is less than equal 1. So that's a divergent p series, and the ratio is 1. That means they behave exactly the same way. So that means by the limit comparison test, sigma a and the original one diverges. Okay, good. So very simple, but this everything you need to write. Uh, so let's go to the next problem. Part C. So in part C, we have n going from 1 to not 1, 2. 2 to infinity, negative 1 n. It doesn't really matter what value you start with unless you need to find the sum. So if you do not need the sum, it doesn't matter what value you start with. Okay, so let's say this is the one you have. So always, if you see that you can easily find the limit, just go ahead and find the limit, because if the limit is not equal to 0, done, because it can converge. That's the n-term test, or the diverging, like n-term test for divergence. So that's how we do. If you can find the limit easily, go ahead and find the limit. So that's normally what we use as the first test. So let's do that. So if you look at the limit, when n goes to infinity, an, because you can see it's very easy to find this limit. So it is the limit, that is writing is important, negative 1 n 7 n cube minus 5, we only worry about the dominating terms, n cube plus n. So if you look at this term, when n goes to infinity, and you can see that they are the same, so that means what matters are the ratios of the coefficient, because they are the same. That means it's gonna go, when n goes to infinity, 7 or 14. That's why it's heading, which is 1/2. So since this is 1/2, what's gonna happen? This gonna change the sign. That means when n is large, they're gonna fluctuate between two values. So what happen is, if you look at in the long run, when n is large, and goes to infinity, so what happened, you're gonna see like positive 1/2 and negative 1/2. It's gonna fluctuate between those two, not exactly, but very close to those two values. So one is positive 1/2, negative 1/2, positive 1/2, negative 1/2. That's what happened. Oh, very close to those values, not exactly, but very close to those values. That means it can fluctuate. So that means this limit does not exist, because this number is almost 1/2, but you have the sign change, so it can fluctuate. That means the limit does not exist. So if the limit does not exist, which is not equal to 0, that means series has to diverge. Okay, so we're going to say by the n-term test, by the n-term test for divergence. That's the test for divergence, n-term test for divergence. By the n-term test for divergence. So sometimes we call test for divergence or divergence test. All of them are the same. By the n-term test for divergence, the original series sigma n diverges. The interesting part is, let's say you forget that, and maybe you try to use the root test or the ratio test, and you can see that the both of those tests fail. So the ratio and the root test fail. The reason is, you can see that n cubed term. So when you have fixed term like n to the k, it's not going to work, because what happened when you try to take the ratio, you see this exact same term, so going to cancel out, and what will happen is you get 1. Okay, in that case, what will happen in this, if you have like n to the k kind of term, it doesn't matter what coefficient you have, but the coefficient get cancelled out. So what will happen is, the limit n goes to infinity, a n plus 1 over a n absolute value, and the limit n goes to infinity, a n, the nth root, both become 1. So that's what they become 1. So it's useless. So test fail. So don't try to use the root test or the ratio test when there's a constant term. Okay. So the ratio test we normally try when you have factorial. Root test we normally try when you have a like a kind of function to a power like that. So some kind of function, not just like in like some complicated functions, because then when you say the root, the n gonna go out and you get that function. So that's a kind of thing. So you can try more problems in the version 2 of the practice problems. So there are like a bunch of nice questions like that, so you can test that. Okay, that's about that. Let's go to the next one. What it says that n going from 1 to infinity, negative 1 n 2 to the n factorial n. So you can see that, you see once you use the factorial, try to go for the root test unless there are some easy cases. There are some times like you really don't need that, because you can try some limit comparison tests or things like that. But otherwise, we just go for the root test, ratio test, not the root test, ratio test. Root test you can use. Okay, root test fail. So the root test fail. Root test not the fail, but you can use it, because what happen is, you need a actually it's not correct. Root test is hard to use unless you know a certain result. uh, so you need to know this result. What's the result? The limit n goes to infinity, fact nth root of factorial, actually this is infinity. So if you know this result, then you can use the root test. You can find, I gave a proof for this one in the channel, so you can find this proof for this. You can show that it goes to infinity. That's a like nice problem for a student in discrete mathematics. Uh, Good. So, if you know this result, then you can go ahead, because once you take the nth root, you can see it's just 0. 0 means it's going to converge. So it's very easy. Um, So let's use the ratio test first, and then I'm going to show you how to use the root test for this problem. So let's use the ratio test. So for the ratio test, we need a n plus 1, which is negative 1 n 2 to the n plus 1 over factorial n plus 1. So let's use the ratio test. So if it's the ratio test, we need the limit. We calculate the row, which is a n plus 1 over a n, and then this is the limit, n goes to infinity, a n plus 1, so which is negative 1, oh actually n plus, mistake, n plus 1, 2 to the n plus 1 over n plus 1 factorial, and then upside down we write in factorial negative 1n 2n absolute value. Since this is absolute value, we don't need these two terms. We normally write similar terms together. These are all positive, so we don't need the absolute sign. And then what's going to happen here is, you can see 2n, you can cancel with 2n, we only cancel n, so you get 2. And we how to simplify factorial? We're gonna pull out the first term, write the rest as a factorial, then what's gonna happen? These two get cancelled. So you simply get limit n goes to infinity 2 over n plus 1. That's what you get, but 2 is a constant. N goes to infinity, though this goes to 0, which is less than 1, because this goes to infinity. So good. So that means by the ratio test, series has to converge. So okay, so by the ratio test, series converge. Okay, absolutely converge and then converge. Okay, so that's about that. So it's very easy. But let's see how to use the root test. So if we try to use the root test, we're going to calculate the limit n goes to infinity a n, the nth root, and then what happens? Limit n goes to infinity. So we have negative 1 n 2 to the n factorial absolute value 1 over n. Now we don't need this. This is 1. So we're going to get limit n goes to infinity to n 1 over n, and here n factorial 1 over n. So that means you're going to get 2 the limit n goes to infinity n factorial nth root. But we know that actually you can prove that, so that's why we cannot normally do this, because otherwise you have to prove this, and this is not obvious. So, and since this goes to infinity, this whole term goes to 0. So that means you get 0. The 0, because the bottom goes to infinity, so that means this is less than 1. So that's how you use the ratio test, root test for this problem. But you need that special information that nth root of the factorial is 1. What are the other similar results that we know? We know that these two, limit n goes to infinity and nth root of n is 1. We also know the nth root of a constant is also 1. Here we assume that a is positive. So we know those two, they are 1. But this is infinity, so that's the problem. They are different. Okay, so this is how you use the root test, but you have to remember that special result if you try to use that. But just try to use when you have the factorial, the straightforward way is to use the ratio test. Good. So that's about that. So let's try to go to the next type of problem. So what's the next type? The radius of convergence problem. So let's do that now. Part E. So this can be like a standalone question in an exam. So radius and interval of convergence. Radius, and let's do both interval of convergence. Okay, radius and interval of convergence. So the problem was sigma n going from 1 to infinity, negative 1 n, x minus 1 to the n, 3n. So this says that, I mean, you can use the root test or the ratio test. So let's use the ratio test, the standard technique. But if you use the root test, it will be very easy because you can already see everything. But I'm going to use the ratio test. That's the kind of standard. But you can use the root test very easily. Okay, so ratio test. So just we can try that. So that means we need the so we're going to call this is the an. So that means we need an plus 1, which is negative 1 n plus 1, x minus 1 n plus 1, 3 n plus 1. So look at the ratio. So limit n goes to infinity, a n plus 1, or a in absolute value, so which is the limit n goes to infinity, negative 1 n plus 1, x minus 1 n plus 1, 3 n plus 1 upside down, so 3n, negative 1 n, x minus 1 n. So there are a lot of simplification is gone, and then this whole term cancels the n term, and then 3n also cancels with this n, so you only get 1 3. Okay, that's the only one you get because n get cancelled. So that means you only end up having, you can see that there are no any n terms, all gone, so you only get 1/3 the absolute value x minus 1. That's the only one you left with. Now what we're going to do for the convergence, we know that this has to be less than 1. So you can see by the ratio test, you can see series converge if 1/3 x minus 1, that's the ratio, that's the limit of the ratio, less than 1. So if you multiply by 3 both sides, x minus 1 less than 3, and that is the r. Once you write in this form, whatever comes to the other side is the r. So that means that's the radius of convergence. So the radius of convergence is 3, okay, or equal to r. Good. So let's say we also need to find the interval of convergence, and let's see how the rest of the argument works if that is the case. Good. So let's find the interval of convergence. So the interval of convergence, what we normally call IC. Good. So for that, what we need, we're going to start with the radius of convergence part. So we have that, and then we can write the expanded form. So what's the expanded form? This means that this is less than 3 and greater than -3. So that's what it means. Now what we can do, we can add 1 to both sides. So again, so from algebra, we know that when you have something like that, when we have x less than a constant, that means the distance from 0 is less than a. That's what it means. Distance from 0 is less than a. That means it has to be a or minus a. That's what it means. It has to be, distance from 0 has to be less than a. That means this whole range. That's why when you have something like that, it means that x is in between a and negative. That's where it's coming from. So here what we do, we simply replace x by x minus 1. So that's the only thing we did. Okay, now you see the argument. So now what we do, we add 1. So that means you're going to be -2 x 4. So that's the interval. So so the interval is, you can see it is between 4 and -2. Now the question is, we don't know what's going to happen at the end point, so we're going to check the end points. So let's say at x equal 4. So let's plug in that in the original series. So in going from 1 to infinity, -1 to n, 4 minus 1 n over 3n. So you can see that 4 minus equal to 3. So it's 3 and 3n. So it is 3n over 3n. So these two get cancelled. So you get sigma n going from 1 to infinity, -1 n. So that means you can fluctuate between 1 and -1. So it's going to diverge. That means that point is not in there. Now we can look at the other one at x equal -2. So let's do that. So sigma n going from 1 to infinity, -1 n. So it's -2, -1 to the n over 3n. So we can also simplify this like this, n going 1 to infinity, -1n, -3n over 3n. We can simplify this like this. We can pull the negative sign out, and then 3n over 3n. So you can see 3n, 3n get cancelled. We combine these two. This is just 1. That means this is going to be simply sigma n going from 1 to infinity 1. That means you're adding 1, 1, 1. So that means it's going to diverge. So that means at none of the points it's going to converge. I mean, you have to exclude all the points. So that means the interval of convergence is simply -2 to 4. None of the points are included. And if you look at the review for power series, I have done some problems using different examples where some of the point included, some at some points they are close. So maybe you can look at that if you need more examples like that. Okay, so that's about that. So let's go to the last part. And also I want to show you like what if you try to use the root test to find the radius of convergence. So let's look at that, and then I'm going to go to the last part of this. So let's see, if you use a root test to find the radius of convergence, what's going to happen. So let's see what happens if you try to use the root test for the radius of convergence. So what we normally do, we can look at the limit n goes to infinity, a n the nth root. So that means the limit n goes to infinity. So we have -1 n, and we have x minus 1 to the n and 3n. So we can take the absolute value and take the nth root. Since this is absolute value, we don't need that term. Now what will happen, this 1 over n goes to both terms. So if 1 over n goes to the first term, n 1 over n get cancelled, so you're going to get -1 1, x minus 1 absolute value, and then if you put that to the bottom, you only get 3. So that's what you get. And then you can see this is, if you are less than 1, is again say that x minus 1 less than 3. So you can see that it's much quicker and you get the same answer. So that's like another way to do that. So we normally do that, we can use that when there are no factorial terms. So try when uh, there is no factorial terms. Okay, if there are no factorial terms, you can use the root test much quicker. Good. So let's go to the last part. If so this one is about power series representation. So let's talk about power series. So we need to find the power series for fx, which is x to the 4 ln 1 plus x. I mean, it can be something like that. It doesn't need to be exactly the same. So what we normally do is we're gonna see how to reach this special term. It's a natural log 1 plus x. So what we do in this problem is we can start with the standard power geometric series. So we know this series. So this is so this gonna converge to sigma n going from 0 to infinity. This is how we write it. This is gonna converge when x absolute x less than 1. So that we know it's gonna converge when the absolute value of x less than 1. So now we're gonna see how to reach from this. So the first thing has to be, we might need to find expansion for 1 plus x. That's how we're trying to do. So you can see the minus. So we try to do 1 plus x. So we're going to start with that. So we can replace x by -x. But if you do that, you can see 1 plus x. which is actually equal to 1 minus minus. So that's the reason why we need minus x. So once you do that, so all the odd terms can change the sign. That means can be 1 minus x plus x squared minus x cubed, like that. That means if you write it, it's going from 0 to infinity. You can see negative 1, not negative 1. So you can see that it is negative x to the n. So you can write this one as, if you pull the negative sign out, negative 1 n x n. So, and the question where this is valid. So what you're gonna do, you're gonna go to the original series and replace this x by negative x, because that's what you plug in. So that means this is gonna valid in negative x less than 1, and you can see that this is still x less than 1 because you can disregard the negative sign since you take the absolute. So it's still the same x. So whatever you replace, put it there and solve. Good. Now we have expansion for 1 over 1 plus x. Now what we're going to do, we're going to see the connection between this and what we need. And you can see that if we integrate 1 over x, you get ln x. So we can use that idea. So we have 1 over 1 plus x, which is equals to, now what we can do, we have this. So what we can do by integrating, if we integrate, you can see it is 1 over 1 plus x dx. So it's an integral sigma n going from 0 to infinity, negative 1 n x n dx. What we do, we're going to switch, and also this is again only valid on that. So what we're going to do is we're going to switch. This one is simply ln 1 plus x, so we're going to get that. And here we're going to switch the sigma and the integral. So it is negative 1, and if you integrate xn, so you're going to get xn plus 1 over n plus 1 plus c. Now we need to find the c. To find the c, what we can do, we're going to say let x equals 0. If you do that, you're going to get ln 1, which is 0, plus c. So this says that c equals 0. So that means ln 1 plus x equals sigma n going from 0 to infinity, negative 1 n x to the n plus 1 over n plus 1. So that's what you get, and you can see this is still valid x less than 1. Now what we can do, we're going to multiply by x to the 4th. So you can see that you get x to the 4th ln 1 plus x equal sigma n going from 0 to infinity, negative 1 n x to the n plus, you have 1, you had 4, which is into the plus 5 over n plus 1 x less than 1. So now the only thing that we need to see whether we can add 1 there, because we know that when you plug in negative 1, it's going to diverge. But you can see that when you plug in x equal 1, what happens is you're going to get the alternate series. So that means you can include 1. So the final uh, radius of convergence can be, because we know that the r does not change. But when you integrate, since you divide by some number, maybe you can include the endpoint. Actually, you can see that that's exactly the case. What happened is you don't have the negative 1. You can have negative 1, but you have 1. So that means you have 1 there. The reason is when you plug in 1 by the alternate series, states series gonna converge. Okay, so this can converge. So that means you have this extra point for this series, but negative 1 is still not there, because if you plug in negative 1, you can see that since this odd power, so series is not gonna converge at that point. So that's the final answer. So this is the end of exam, final exam review version 1. So I hope this will help you to do well in any calculus 2 exam. So we see more problems in the version 2. In version 3, we can look at polar coordinates and parametric curves, including the conic sections. Thank you. So I'm going to show you next some common Maclaurin series. So that's going to help you for certain problems.